heard say the word open source, and he's probably the biggest advocate of it. So I know you'll enjoy his talk, and see you soon.
Thanks, man. Welcome, guys. So, my name is Phil Dibowitz. I hold many hats depending on where you've met me. I am a co-founder of SCaLE. I am a production engineer at Facebook. I do a bunch of different things. Today, on this stage, I am not wearing the SCaLE hat. I am wearing the Facebook hat. So if you don't like the things I say, you can go yell at Facebook. Don't yell at SCaLE. So today I'm going to be talking about building open source relationships from within Facebook. And Facebook has been building relationships for a long time in the open source community, but this is specific about my team and how we did it, and how we changed how we were doing it specifically, because we'd already been doing it. And I want to take a quick moment to note that while I am the only person on the stage today, a colleague of mine, Davida Kalvaka, helped me build this talk and gave it with me in Brno, Czech Republic in the freezing cold in January. So thank you to Davida for his help there. And there's one disclaimer I need to make, which is I'm talking about my experience, and I'm talking about my team's experience. This is not to say that every other team at Facebook is perfect at this or terrible at this or that nobody else does this. Open source is part of the ethos of Facebook, and lots of different teams work with the community in a variety of different ways. And this is our story, and we will go through a little bit of the history outside of my team, but fundamentally this talk is about what my team did. So who am I and why the fuck should you care? So I'm the tech lead of the operating systems team at Facebook, and what that means is we work with the bare metal experience. So we are responsible for Centos. We're responsible for configuration management, which in our world is Chef. We're responsible for packaging infrastructure, so the Yum servers and tooling around building RPMs and deploying them and the rate of change there. We're responsible for the systemd and how we interact with all of the community sort of below the container layer. And what that means is that our customers are any service that runs on bare metal, which in our world is databases and large storage infrastructure and those sorts of things, as well as the container management system we have internally. They're our direct customer, and then every other thing at Facebook is sort of their customer, right? This is our agenda. We're going to talk a little bit about open source at Facebook first, give you a little history, a little overview, some of the good, some of the bad. I'll be super honest with you. And then we're going to jump from there into why would you want to do this, and given this is an open source conference, I'm pretty sure most of you know why you would use open source or why you would release open source, but at the same time, you may not know why it's important to invest a lot of your personal time and effort into building relationships with these communities. And even if you do, you may not know how to communicate that or articulate that to your management and to the rest of your company. So we'll talk about that. And once we've talked about why you want to do this, we'll talk about how to do this. And then finally, the meat of this talk is the examples. It's not actually the meat in terms of minutes on the clock, but it's the important part. So we'll talk about very specifically the last year and some changes of my team, the relationships we built, the good, the bad, and then we'll end with some lessons that we learned. So no discussion of open source at Facebook would be complete without mentioning the open source team, so I'll start there. We have an open source team at Facebook. We've had one, I've been at Facebook for 6.5 years, and we've had one since way before I got there. Open source has always been part of the ethos of engineering at our company. So the open source team has grown and changed over the years, but primarily their job is to help shepherd projects into open source. And that means stuff like, hey, I wrote this piece of software internally and it's awesome and I think that every other company out there would love it. I don't know how to do that because this chunk here talks to foobar internal service and like, what do I do with that? And they'll sit there and help you go, well, we could factor this out into a plugin or a config file or whatever, and here's how you'd make this something you can release. Or you may sit down and say, hey, I'm about to be tasked with writing this service. I'd really like to make sure that when I'm done writing the service, it's something that I can go to legal and get open sourced. How do I do that? And they'll talk you through doing that. They'll talk to you about when you go and say, hey, I'd really like to open source this. They can look at it and say, you know, I'm not sure there's a community for that. Are we just open sourcing it to say we did? Or is there going to be actual value in the community because there's a cost? There's a cost to us, there's a cost to the community when you open source stuff, and we don't want to do that. And the converse of that, hey man, this would be really good for the community. But from what I understand, there's one person on your team who's way oversubscribed. Are you going to have time to accept pull requests, to look at issues, to build a community, to be a good community member? Because if not, maybe we shouldn't open source it. They can help you understand and navigate the legal waters. They'll work with legal with you. They are very technical and also very well educated on the law. So they will sit there and be that kind of middleman for you and help you to understand what the lawyers are saying and help the lawyers to understand what you are saying. At the same time, they build a lot of tools. There's an open source tool called ShipIt that they have open sourced. That was redundant. And what it does is it can take internal repositories, Git, Mercurial, whatever you've got, and sync it to GitHub commit by commit. And this is really different from the way a lot of big companies sync out their internal repos. Instead of taking the last day or week or month or quarter or year of shit and dumping it into GitHub where you as an external contributor don't know how you got there. Today you're in Los Angeles and then tomorrow you're in New York and you don't really know how you got there. This actually goes commit by commit. And so you can see as these commits are happening, what's going on. You can see the commit message and the code that's changing and who's doing it. And generally speaking, it's like between 15 minutes and a day out of date. So we're talking a lot, essentially live changes, depending on the team and how sensitive it is. And even better, your internal engineers actually get credit for what they're doing in the open source community, which is nice. So they built a bunch of other tools to keep in sync bug reports and blah, 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 blah. But fundamentally, they provide guidance. That is their primary motivating thing they do, is they provide guidance for internal engineers who would like to open source something. When Facebook started, as I'm sure most of you know, sorry, I'm losing my voice, a week of partying, it started as a lamp stack in Mark's dorm. So he wrote a PHP app, and that PHP app ran on Apache, and it talked to MySQL on a Linux box. We all know that, many of us know the standard lamp stack. So open source has been part of our history literally since day one. And how much we used of it and how much we contributed to it has grown and shrunk over the years, but it's always been a big part of who we are. And so as the company grew, PHP turned out to be great in terms of onboarding new engineers, but it turned out to be not so great in terms of scaling the site to what would eventually be more than 1 billion users. So people started working on Zen PHP. They started contributing patches. They started trying to improve performance, and they succeeded. But they didn't succeed like orders of magnitude, which is what we were looking for. So another team sat down, and they wrote a thing called HPHP, which eventually got open sourced as hip hop. And hip hop was a thing that took your PHP code and compiled it down to C++ and stuck in a little embedded web server in there. And then you could take that C++ and compile that down to a binary, and you had this huge monolithic front-end binary that was like a big Linux binary, but it was fast. It was super fast because it was compiled, and that was our front end for many years. And we open sourced it, and other companies started to use it, and it was pretty successful. But there was a huge drawback to this. If you're a developer, running your code, your massive code base, through 2 compile passes does not make for quick coding. You're like, I made a one-line change. Let me hit compile and go get some coffee. And let me come back and hit compile again and go get lunch. So what ended up happening was all these developers were continuing to use Zen PHP in their development model, and then using this entirely different runtime in prod. And for those of you who have worked in the industry, you know that like having dev and prod being different, not really what you want. And they were very close, and it mostly worked, except when it didn't. So eventually a team sat down and said, well, I think we can do one better. And so they wrote a just-in-time compiled VM, a JIT VM for PHP, heavily, heavily optimized. And it took a while to get the performance on par. But once they did, they open sourced that as HHVM, and that's what we run today. And many other companies actually run this today. And it means that you can develop quickly, and it's really, really, really fast. The interesting part of the story is not the technology, it's not the speed, it's not how they did it, it's not the order in which they did it. What's really impressive about the story is that team today continues to work with Zen, continues to work with the PHP community. They're part of the working groups, they contribute to the standards, they still send patches to Zen when they want to have a new feature added. They make sure that the thing they're writing is a compatible runtime for PHP. They didn't have to, right? They could have just started with PHP, forked off, and been like, look at our cool language, aren't we awesome? But they didn't. They continued to be a part of the community that they came from, and I think that's awesome. MySQL is another really good example. Sorry, I don't have notes up here, so that's why I glance at my slides every now and then, figure out where I am. So MySQL is another great example. We've contributed to MySQL for a long time, and we're one of, if not the largest, installation of MySQL in the world, which means that we have a MySQL team, and they develop on MySQL, and they add features, and they do performance fixes and bug fixes and all of that sort of stuff. And there's a really good MySQL at Facebook engineering blog. If you guys are interested in that sort of stuff, you should follow. In the early days, as they were developing on this, they would send patches up to MySQL, and then MySQL got bought by Sun, and then Sun got bought by Oracle, and this became kind of fuzzy. And those of you who follow this know that it was a tumultuous time in the MySQL universe. And eventually, we ended up putting patches on GitHub because they took a while to get through stuff. I'm not going to say too many words about all of the internals of the MySQL community, but suffice to say we ended up putting patches on GitHub just to make sure people could see them. And eventually, Facebook, Google, and a bunch of other big .com tech Silicon Valley companies decided to get together and work together on all of these things they were doing to help improve MySQL, and they made a thing called SCaLE SQL. And you can go find it today. They have a web page and a GitHub repo. And that worked for a while. For a couple of years, all of these companies were working together to improve the performance of MySQL. And there was a single GitHub repo, and everyone was one big happy family. Eventually, these different companies decided they wanted different things to be performant within the code base, and they were somewhat at odds with each other, and so they all went their own way and worked on different forks of MySQL and what have you. And today, what we basically do is we have a GitHub repo under our organization that's just MySQL, and it includes like MyRocksDB and a bunch of other stuff. The thing, again, that's impressive about the story is not MyRocks or the way we contributed patches or anything else. It's the fact that through this long history, ups and downs, that team continued to work very hard to find the right way to interact with the community, to provide what they were doing, to be good community members. The kernel is another really good one. So before I came to Facebook, I did not give, and I still don't give a shit about social media. I just couldn't care less. But I do care about scaling technology. I really, really love it. So I was at SCaLE, actually, and I was being recruited by Facebook. I was at Google at the time, and I was like, social media. And I started looking into Facebook because people kept telling me, oh, there's a cool open source company. And I was like, really? Big blue box? And one of the things I found was that they had they contributed a massive patch set to greatly improve UDP performance in the Linux kernel. And no one had ever looked at UDP performance before this, as far as I could tell, because it was basically just for DNS, and no one really cared if you could squeeze a couple extra milliseconds out of that packet. But it turns out that at the time, Facebook was using UDP for all of their cache traffic, so they cared a lot. And so they basically rewrote UDP in the TCP/IP stack, and they contributed it. And I thought, well, that's cool. Maybe I should go look at this company. So that's kind of one of the things that made me start looking at the company. I get the job. I don't work on the kernel team, but I work with the kernel team, being in the space that I'm in. And the team grows, the company grows. We go from thousands to tens of thousands to hundreds of thousands of servers, from millions to tens of millions to hundreds of millions to a billion users. And the number of machines grows, and the things we need from those machines grow, and the kernel team grows. And the way the kernel team worked for a long time was, here's a kernel. We have 9 billion patches on top of it. Now we'd like to move to the next kernel. Great. Get next version of kernel, forklift billion patches on top of new kernel. And for those of you who are software developers, you know that this is a terrible way to do anything. It's very painful. It requires a lot of work for each one of those patches to like try and remerge it and all of that. And so eventually, as the team grew and started to get more prevalent kernel developers on it, they decided that this was not going to work. And they moved to an upstream first model. And so they said, okay, we're just going to drop all those patches. We're going to take the Linux tree. And we're going to go one by one through these patches, and we're either going to submit them upstream and get them upstream, or we're going to drop them with like one or two corner case exceptions. And there's always like the one thing you need or whatever, right? And they did. And it took a couple, I don't know how long it took, but eventually they got to an upstream first model. And today, we never develop a feature on an internal kernel, ever. Every feature we write in the kernel is written, submitted, and accepted in Linus's tree before we deploy it. And it doesn't mean we don't deploy it on a machine to test it or whatever, obviously, but we don't backport to our live production kernels until after that patch has been accepted. And the kernel team wrote a really good blog post that's linked to in the end of my slides about this transformation, about how they made this. And the thing that came out of this is, well, the things that came out of this are many. So first, when we want to move to a new kernel, instead of having to move a bunch of patches, we just drop patches. Because when we move to the new kernel, all of the patches we're carrying are already in the next kernel. So we just drop them all, or at least most of them. So moving kernels is much, much, much faster. And when moving kernels is much faster, you move kernels much faster. And when you move kernels much faster, you're doing less backporting. And when you're doing less backporting, you have more time to write more features. And when you have more time to write more features, you're doing better. And then you move faster. And it's a self-feeding cycle. And that's great. And that team is awesome. And that change helped to recruit more kernel engineers because they're not working on 2.6.24 or whatever. They get to come and work on Linus's tree. It's exciting for them. So again, the moral of the story here is not the work we do. It's the way the team worked hard to do the right thing to engage with the community. Of course, we haven't always been so perfect. HBase is a different kind of example. So we forked HBase really early on. Some guys sat down, some developers decided that they could make this better, and they started writing patches, and they started improving performance. And part of the ways they did that was by leveraging a lot of internal Facebook infrastructure. And they kept doing this until such time as it became very difficult to move patches back and forth between our internal fork and the upstream fork. And hubris is a thing that exists. And they figured, we know better. We got it. We got this. And so they did, and years went by. And then eventually somebody joined the team who said, we should just try the open source version just for fun. And they did. And what they found was it was way faster in tons of different metrics. I put a bunch of them up there, like halved average latency, long tail latency was reduced by more than 90%, a bunch of other stuff. There was like a couple ones that I picked up, but there was more of them. And so immediately they were like, we're doing it wrong. And so they started a project that took some time to move to the upstream version. And they took any patches that they actually needed and they submitted them upstream, and today we're on fully open source HBase. And that same team learned their lesson and went, we should do the same thing with Zookeeper. And so Zookeeper is one of those things that we had forked internally. And they looked at it, and the upstream version had become much better and faster. And so now we're in the same process with Zookeeper. Chef is a very different example than both these two, not necessarily initially positive examples, as well as different from the other examples I gave. There's a whole slide on this later, and we're going to go more into our relationship with Chef. But fundamentally, the reason that I pointed out here is for 4 years, we've engaged with both the company Chef as well as the community Chef. We've worked very hard to have a relationship with both of them. And this has been great because for 4 years, we've had a terrific relationship with them where we've been able to add features, we've been able to request features, and it's generally been a very, very positive relationship all the way through. We develop a ton of other stuff, right? I picked a handful of examples that I could use to show morals, but the reality of it is Presto, OS Query, React, RocksDB, McRouter, Buck, Surround 360 processor is a small sampling of things that we develop in the open with the community. And if you go look at the GitHub repos for these, what you'll see is that it's not just Facebook employees contributing and the occasional pull request. There are people from the community who are actively engaged, who are actively developing on this, and the commit logs show it. Most of these things are actively developed with the community, and several of them have external contributors who are maintainers. So, and again, this is just another small list. We have tons of them. So that's a little history. Now let's actually talk about why you might want to actually build these relationships more than just, say, release your own software. So a lot of these reasons that I'm going to go through sound a lot like the reasons that you might want to use open source software in the first place or release some internal piece of software, and that's because they're related, right? So the first reason is that it's efficient. We've all heard that, like, okay, you have some internal piece of software that you've written, and if you open source it, well, now you're sharing maintainership with a bunch of other people, and you're not the only person who has to sit there and make sure this goes. And the same thing holds true when you're engaging with a community. When you're engaging with a community, rather than keeping some patch set internally or a bunch of workarounds, which is more often the case, because some piece of software you're using in your distribution, whether that's Red Hat or Debian or Mint or whatever you're using, it has some bug, and instead of actually engaging with this community, you make some crazy-ass workaround in your configuration management or in your container system or whatever. It's more efficient when you can actually engage with the community and say, hey, look, I really kind of wish this worked this way, or I really wish this had this feature, and either contribute it, or because you have a good relationship, they go and do it. So that always means less man hours because you're not maintaining these patches, these features, whatever. And as you build these relationships, now all of a sudden you're able to contribute code more easily. I don't know how many of you spend a lot of time on GitHub, but drive-by pull requests tend to get merged a lot less often than the people who are engaged on the mailing list or on the IRC channel or in Slack. And as you can contribute this code easier with less stress, with a conversation, it means that you generally tend to be happier about your life. Your engineers are happier, and that's always good. And they feel that sense of community and that sense of shared ownership, right? And it's more people who are maintaining these features you've written and these bugs you've written or fixed. And then finally, the obvious, more eyeballs equals better code, which I'm aware is not always true. But it's more likely to be true. The more people who are using your code, and the really big benefit of this is unlike, hey, I dumped some code into GitHub that no one's ever heard of, as opposed to, hey, I put a patch into Bind, for example, there's a bunch of people using that software already, so they're going to get those bug fixes, and they're going to see those features, and they're going to poke at them. And so your code's actually more likely to get tested. There's also less waste. So imagine instead of being super engaged with community X, you use version 7 years ago that happens to be in rel 6. And you're like happily chugging along on version X of whatever this package is, and it's really old, like really, really, really old. And then you have some bug. And so you spend some time debugging the bug, and you're doing S-traces, and you're taking debug logs, and you're doing all the stuff, and you're being the awesome engineer. And then finally you find this bug, and you write the patch, and you're like, great, I fixed the thing. Look at me, open source hero. And you go to submit the pull request, and you're like, that doesn't look like this, fuck. And so then you spend like 3 more hours forward porting it, only to find out that that bug was fixed 2 years ago, and you just didn't know. Man, you just wasted a lot of your own time. I've seen this happen time and time again. Or let's say that you don't have the time to fix that, so you spend 2 hours and you write up this super awesome bug report. Man, you've got the S-traces, and you put them in Markdown, you highlighted the right things, you've got here's my tarball of logs, here's all of the stuff, here's my environment variables, I gotcha. And now this maintainer sits down, and he sorts through a terabyte of data you uploaded, only to find out he fixed that bug 2 years ago. It's not going to go well for you. These things cause animosity, they waste your time, they waste other people's time. This is not good. As opposed to being on something very modern, where you probably didn't run into that bug, or when you did run into that bug, by the time you fixed it, you were able to contribute this, and everyone was happy. Another good reason is direction. So knowing what's coming down the pipeline will make your life easier, whether you're on the more operation side or the more developer side. Say, knowing that the next version of your OS is going to have systemd and networkd and whatever else, that's much better than being surprised by it. Like trying to roll it out and being like, oh, look, my init scripts don't work. Or my configuration management that writes out a bunch of ifconfig files doesn't work, or whatever. And it can be small. It doesn't have to be these huge, massive things. Let's say you wrote something that uses netcat. Netcat's options change drastically between rel 6 and rel 7, CentOS 6 and CentOS 7. Like just knowing that's coming, knowing that they change where they're getting netcat from can make a big difference if netcat is your thing. If you're like, all of my stuff sits on top of netcat, knowing what's happening in the netcat community will help. So there's a bunch of different examples like this. But here's the thing. If you're involved in the community, when you get to have that conversation is not after it's been committed and then packaged and then sent down the pipeline and then you downloaded it, because you're not going to change their mind at that point. But if you're on the mailing list and they're like, oh man, I think we should change from library foo to library bar, and you're like, dude, that's going to drop these 6 features that I really, really, really need, now you can actually be a part of that discussion. You can be a part of the direction of the community without even being a developer, right? This means that you're engaged with the community and the community is engaged with you, so that you can actually start to be prepared for these things and be involved with these conversations when they're meaningful. It's not meaningful to have that conversation 4 years later. And then as you do this, and as people start to respect you, and as people start to think, man, that John guy, he's got some good ideas. Like, he's always given us good feedback. Now when you jump on the list and you're like, hey guys, I got an idea. We could do blah. You're more likely to be heard, right? It's a community. There's clout, right? Engaging with a community more often is going to mean it's easier the next time you do it. We all talk about how code wins arguments, and it does. But every line of code was written by a person, or code that was written by a person, or code that was written by code that was written by a person. It all comes back to people. You, me, you. Somebody wrote the code. And you have to think about that, because it turns out that when you're engaging with the community, you're not engaging with that code. And I love daily engaging with code, because code is not weird and mushy like people are. And people are like unpredictable and do weird stuff. But at the end of the day, you have to realize that you're dealing with people. So when you start to build these relationships with the community, and your engineers get to start contributing their code upstream, start being a part of all of these communities that they know of, that they've heard of, that they've consumed for years, but now they get to be a part of that community. They're happier. And how much research has been done that shows that happier employees are more dedicated, work harder, do better work, right? So it's better for your company. And the thing that I've talked about a lot is being engaged with the community, but it goes the other way. So as an example, there are a handful of pieces of Chef that Facebook are super sensitive to changes on. And when somebody submits a pull request to one of those spaces in Chef, it is very common that somebody in Chef will tag me or one of my coworkers and say, hey, what do you think of this pull request? Because we're not just engaged with the Chef community, but they're engaged with us. They know what we care about. They know what we've contributed to. They know what bugs we've filed. They know how many times they've broken us or nearly broken us. Right? So it goes both ways. And then there's this weird thing where, like, we did not at all plan this. This was not a goal. But what we got out of this sort of superfluously was better recruiting. When we were out there talking about what we're doing, contributing code, having discussions, people are like, man, Facebook uses that thing that I know, that I use. They're not just this weird box somewhere that does their own thing. And so people started coming up to us at conferences being like, hey, do you have any open positions? I really like working on blah, 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 too. So that was really nice. And then good relationships are contagious. There's an example later in the talk about a sort of fortuitous happenstance. But that wasn't me, was it? No? All right, good. But the reality is that if you're engaged in some community, you're a contributor, you're a great bug reporter, you're the person answering questions on IRC, whatever it is, and then all of a sudden you want to engage with this other community, there's a pretty decent chance that like one of the maintainers or contributors to Project A happens to be involved in Project B. And so now you've already got a foot in the door. Now you've already done the first step of building a relationship. Good relationships are contagious. So with the why out of the way, let's talk about how. And the how really boils down to one thing, and it's building social capital. Fundamentally, building those relationships all comes down to having social capital. So how do you get social capital? What does that mean? Well, there's a bunch of ways to do this, but the first thing, the primary thing, is wherever possible, do this in person. Want to get involved in System D? Go to System D-Conf. Most major projects have a conference around them, and if they don't, they probably have a meetup around them. Go to the meetup. If they don't have a meetup or a conference, go to a conference that's related where those developers may be. Go look and see if somebody's giving a talk on that at some nearby conference. Go to the conference and meet these people. Go sit down with them, have lunch, have a beer. If you can't do that, if this piece is offered owned by a company, send them an email. Ask to go to their office. Get on a plane. Go find them. Have a meeting. Sit in their office. Tell them why you like their software. Tell them how you would like to engage with their software to make it even better. And if they're not, maybe you can invite them to your office. Hey, I know you guys are only 2 people working in a garage. You want to come and see the Facebook campus? Want to come? Maybe you don't work for a company with a really cool office, but you work in, say, Manhattan. And you're like, hey, want to go to a cool steakhouse in Manhattan, right? Invite them to you. Pretty much anywhere. We all know that it's so much easier to have discussions with people you've gone and had a drink with. Participation is important. Go find whatever mechanism they use for communication, whether that be Slack or IRC or mailing lists or whatever, and join and listen. But then participate. You actually have to be part of the conversation. It's not good enough to be a lurker. Engage. When they start talking about things that you care about, respond. As you respond, as you be engaged with these people, they'll know who you are, and you start to build a relationship. Again, go to relevant conferences and meetups. 2 other things, and understand the goals of the project. Talk to them. Figure out where it is they see this project going. Because if they see this project going in some direction, and it's the opposite, the antithesis of what you'd like to do, it's going to be a harder conversation. And you should probably know that going in. Or maybe you really want this thing to come out of this project. And what you find out from talking to them is that they also want that thing, and they're already working on it. Or they were excited to work on it, and they want to help you. Understand where they're going, but also understand their workflow. It turns out you're not going to get every open source project out there to use your workflow. If every time I went to an open source project, I was like, yeah, I mean, GitHub's cool and all, but I think you should use Fabricator, which is our code review system. I don't think I'd get very far, right? You're engaging with their community. You need to meet them with their tools and their best practices and their approaches. So read the docs, figure out how they do testing, figure out how they do code reviews. Maybe they're an international team, and so after someone in the U.S. approves your pull request, they're going to wait 48 hours so that the offices around the world have 2 days to look and complain and say, no, I don't agree. Hey, you didn't know about this thing. And maybe if you don't know that, you're sitting there going, oh, come on, merge my pull request. Maybe they have protected branches. Maybe they have specific internal rules. Big companies often have a lot of rules about backporting changes to release branches. Maybe they have a bunch of internal, takes them a month to do it, and so they're just not going to do it. It's important to know these things. Context is everything. So understand their context. Kind of taking on from the previous slide, when we worked with a bunch of different teams at Red Hat, what we found out was any developer could merge a pull request onto master, but if you wanted something on the RHEL 5 or the RHEL 6 branch or the RHEL 7 branch, that was stuff had to happen, a lot of stuff. And we're like, oh, well, that's good to know. So any place where we can be on a release that's not directly from the distro, it's much easier for us to contribute. Easy peasy, done. So understanding their context, we worked with a team that had a project that had a team in Brno, Czech Republic, and so they would add a tag that says one side of the team has approved this, and you had to wait till the other tag was added that said the other side of the team had approved it. This was their way to make sure that there was balance and you didn't miss context while the other team was sleeping. But then provide your context. If no one likes a 20,000 line drive-by pull request, they just don't. No matter how awesome your pull request is, no one likes a 20,000 line drive-by pull request. Provide context. If you're going to rewrite a subsystem, jump on the mailing list. Say, hey, I have this really cool idea to rewrite the subsystem. How do you guys feel about that? Here's why I think we should do that. Here's what we're going to get out of it. Here's why I don't like the existing one. And what you may find out is someone's like, oh, yeah, I'm already halfway through that. Give me a week. Or, oh, yeah, that'd be great. Let me help you with that. Or, oh, no, that idea is fucking terrible. We tried that already. Right? So provide your context before you go and spend a month writing a bunch of code that you're now personally attached to. And when they tell you they don't like that idea, you're going to be really angry. But if you haven't written the code yet, now you can respond better. Remember to find the appropriate medium for the conversation. If you want to make a 3-line typo fix in their comments, maybe don't fly across the country and have a conversation with them. Maybe not necessary. But at the same time, if you're going to do that drive-by, or if you're going to do a massive refactor, maybe don't put a 1-line commit message. So one of the biggest, most difficult things about actually being engaged with the community is figuring out the right speed for you and for this project. This turns out to actually be quite challenging. What you want is to be following the project close enough to be able to engage meaningfully in both code contributions and discussions. And this is the key. In fact, I should have put that quote on the slide. I don't think I did. So the idea is you want to be following something equivalent to latest, and latest is going to change a little bit based on the context. And you have to make a lot of considerations as you decide what this means. So you have to think about the cadence of this project. If this project is getting 600 commits a day, and they're releasing twice a week, probably upgrading yearly is not going to be enough for you to have meaningful context on what's going on in this project. At the same time, if they're getting 100 commits a year and releasing once every 6 months, maybe trying to download, master, compile, and push it out every day is a waste of your time, right? So you need to understand the velocity of their development and the velocity of the release cycle, and these are not the same. Some places release very regularly and get very little in terms of contribution, and some places are getting tons and tons of commits but never releasing, right? You actually have to understand both. You have to understand your own resources. If you have one person on a team who is swamped, maybe upgrading and pushing out this random piece of software you like to contribute every day is just not feasible. And so you have to understand that. And you have to understand your own, maybe this is a piece of code that you're putting into another project where you only release it once every month. And if so, does it really make sense for you to be trying to pull in the latest every day? So it's important to understand both of those things and pick a velocity that's going to allow you to the version you're actually running and familiar with to be close enough to what the developers are developing on that you can meaningfully contribute and get things out of discussions. And finally, be honest. That sounds silly, but it's really, really true. If you come into a community with false pretenses, and you're like, oh, dude, no, I'm just here to be a better community member, and that's it. I have no other ulterior motives. It's not going to go very well for you. Be upfront. Hey, I need this. These are the things and the problems I'm running into. Here's what I think I can contribute. Here's where I'd like to see the project go. And there's ways to work this into a conversation, but fundamentally you have to be honest. And then, in turn, you can expect them to be honest with you. So, our journey by example. So as I said, over the last year and a half, my team, the operating systems team, has worked really hard to expand the relationships we had, to have more of them, to have deeper, better relationships with the community. And we sat down kind of late 2015 or so and started thinking about how we could do this because we really liked the way we worked with the chef community. But we had all these other projects that we were like, man, we work around these bugs, or we're already on really old versions, or we don't know how to contribute, or whatever. Like, we should really try and grow this thing that we do pretty well over here. Can we do it better in more places, and how do we do that in a sustainable way? So there's a bunch of considerations you need to make as you try and pick projects that you might want to do this with, and we'll highlight these as we go through the examples, but you need to make sure you're clear on what your goal is. You need to figure out what kind of speed, per the previous slide, is reasonable for you. You need to figure out the size of the change you want to make, because that's going to change the engagement you're going to have. And then not so much applicable to these examples, but something you should keep in mind is, were there previous engagements with this community? So let's say you want to engage with the community, and you've never engaged with this community, but the team that sits 15 rows down from you in the building tried to engage with that community and were complete assholes, right? Like, this is going to affect your ability to build that relationship, and you probably want to know that, because they're not going to know you're a different team at Company Foo. They're just going to know Company Foo, who was a major asshole to me 3 weeks ago, now is trying to contribute to my project. So being aware of these sorts of things can make a big difference. So when we sat down to figure out where we were going to go next, the first thing we had to do was take stock of what went well, what we had done already. And as I said, we have a great relationship with Chef. So we had been building this relationship for a long time, and we had intentionally decided that our relationship had to be both with the community and with the company. So we buy support from Chef, and so we can make support tickets. But if we ever have a problem with anything that's open source, which is the client and now the server, but for a while there was a closed source server, we would always file that bug on GitHub in the open. And if we felt the need, we could go and file a support request saying, hey, we, big customer, care about that GitHub pull request. But we never filed those just internally because we wanted to engage with the community. We didn't want someone else sitting there debugging a bunch of stuff that we'd already debugged. When there was 2 Chef servers, even though we paid to get access to the proprietary Chef server, which had features and bug fixes ahead, we always ran open source in at least 10% of our clusters. And the reason we did this is because we made a promise to the community that any work we do, any tooling we write, you guys should be able to use. And the only way we could guarantee that is if that tooling worked with open source Chef. And the only way I could guarantee that without having to set up way too much tooling was to just use it in prod, so I did. So when we sat down, we had a goal. And our initial goal, our goal changed over time, but our initial goal was scaling. So when we looked at a bunch of config management systems, Chef scaled the best, but it didn't scale enough. So we were like, cool, let's sit down and engage with them, and we talked to them. And they were giving us builds like a couple times a week. So we were running things like chef server-foo-facebook-git hash. Because some developer would be like, I think I fixed the thing, compile, make RPM, email to us. And we were upgrading constantly. And that was the velocity we needed to give them the feedback they needed in order to actually get where we wanted to go. And we had dedicated the resources to keeping up. Eventually, SCaLE hit a place where we were like, yeah, we don't care anymore, it's fine. And so we stopped doing this. And we got on a major release, and the world was good, and we had a different goal. And that goal was to add features to the Chef client. So we started adding features to the Chef client, but what we found was the rate of development on the Chef client was different from the rate of development on the Chef server. And so we were actually able to keep up without having to upgrade daily or weekly. We could actually be on kind of a quarterly release, and it was more than sufficient to know what was going on, that plus following the mailing list and pull requests and stuff, and be meaningful contributors and have meaningful discussions. So we got to a point where we upgrade both about quarterly. And so the point here is that we picked a goal and picked the velocity based on that goal, and when our goal changed, we changed the velocity. The velocity is not just about the project, it's also about the timing. We got involved in community events. I've given talks at Chef Conf. I've been on panels. I've gone to the Chef Developer Summit, as is most of the people on my team. They've given talks. We've tried to stay involved with the community as much as possible. And the benefits of this relationship are many. They developed IPv6 support for us in the Chef server. They massively scaled the Chef server. We contributed multi-package support. We contributed much improved systemd support. When the client side of Facebook started using it for desktops and laptops and stuff, they contributed significantly improved OS 10 support. All of these things the community benefited from, the company benefited from because they could sell it, and then we obviously benefited from it. So all around. And as we talked about these things, people were like, dude, you wrote what for interacting with Chef? We would like that. And because we had had this relationship, because we had worked to make sure we were using everything that was open source, it was very easy for us to release the tooling in a lot of our cookbooks. So there will be a link towards the end where you can see the tools in the cookbooks we've released. So with that said, we had to pick a thing. And how do you pick a thing? We work with hundreds of pieces of software, at least. And so we kind of looked at it like, okay, well, what are we working around? What have we had? Do we have internal patches for? What meaningfully could we actually contribute to, like, today? Like, if someone said, great, we'll interact with you if you can deliver us some useful pull request within the next 6 hours, like, what would that be? And there was a handful of them, but this narrowed it down pretty significantly, and one of them was Anaconda. Now, Anaconda, for those of you who don't know, is the installer for Fedora and Red Hat OSs, so Fedora, RHEL, CentOS. It is both the installer you get when you plug in the CD and get the pretty thing, as well as the network-based installer. And so while we do not use the pretty thing with CD, we do use the network-based installer. And the thing about the way they build and develop Anaconda is when they fork the code for a given Fedora release, say Fedora 26, for example, in master they drop every feature that would be required for 26 but not 27. And they continue to develop those features on the 26 branch, and in master they do only what's required for 27. And one of our goals was we wanted one installer for all versions of ROS. As you can see, this isn't really a pull request. This is like a, hey, would you mind changing your entire fucking development model? So that was going to be a problem. We had features we wanted to add. That was great. The other thing we wanted to do was we wanted to be able to use the latest bleeding edge version of Anaconda because it had hardware fixes and IPv6 support, and we're a huge IPv6 shop. So with our goal in mind, it became very, very obvious that step one was send them an email and say, hey, can we come to your office and talk? And I did. And so my colleague Brian, who's sitting up here in the front row, and I flew out to Westford, Massachusetts, which is in the middle of nowhere, and that's where the Anaconda team was at the time. And we met with them, and we started that conversation very simply with, what does being a good community member look like to you? And they were like, what? And we're like, community members, like people who use your software. Like, what would be a good way of doing that? How can we be helpful? And they had to think about it, and we had a conversation about it. And then we asked them where they were going and why they did the things they did and why they developed the ways they did and what their branches meant. And they were really excited to tell us about all this stuff, and they were like, okay, cool, and they did all the things. And then we said, cool. Within that context, we were now able to talk about the things we wanted, within the context of what they wanted and how they developed. And that conversation went really, really well, because one of the things that they really wanted was people to be able to actually be using the code they were writing, not the code they wrote 6 years ago. It makes it much easier to actually go and track down bug when you don't have to be like, wait, what was I doing 6 years ago? So they were super excited about our idea. And they said, great, let's just spend we were out there for 2 days, and then halfway through the first day they said, let's just hack. Like, next 2 days, we're just going to sit down and we're going to just hack. We're only going to write code. Okay, and that's what we did. We just sat there with them and we hacked on code. We went back to California, kept in touch with IRC, and over a couple of weeks, all of those pull requests got merged. And today, instead of being on whatever thing happened to have been released 4 billion years ago in CentOS 6, we cut a master build every month, give or take, and roll it out. We have one installer for CentOS 6, CentOS 7, Fedora Rawhide. It'll do them all. This code has no internal patches. It's all in GitHub Master. We have the latest hardware support. We have the latest IPv6 support. We've dropped all of our internal weird workarounds. So, yeah, pretty awesome. So we thought about the speed and we thought about all these things, but primarily what we got out of it, what's interesting about the story is figuring out the right speed and the right engagement model, right? And so today we still continue to to communicate with them well, contribute stuff. We saw them. My other colleague, Davida, and I went to Brno for a DevConf, big Red Hat conference, sat down with the Anaconda team, hung out with them, and we've continued to make a great relationship. So the other one that we decided was potentially useful was systemd. Now, we had started moving from CentOS 6 to CentOS 7 in late 2015. Sorry, I had to do math. Math is hard. And with that, most of you probably know, comes systemd. So it was very obvious that systemd was going to become this like very core underpinning of our infrastructure, and we couldn't just ignore it and be like, yeah, it's fine. Right? We had to actually engage. We had to actually think about this. And so as we looked into it, what we realized was there's a lot of really awesome features we wanted out of systemd, and none of them were in CentOS 7. They were all like way later. And so we're like, well, that's cool. Like, maybe we'll look at backporting those or something. And the other thing we really wanted to do is we wanted to have cgroup 2 support. So Tejan, who's actually giving a talk on cgroup in the exact same time slot in some other room, which is interesting. He is the primary maintainer of cgroup in the kernel, and he wrote cgroup 2. And we really wanted to use this, but all of the support for cgroup 2 and systemd was like weeks before this moment in time, not years before this moment in time. So we're like, okay, can we backport all this crap to CentOS 7? And it turns out that that's a nightmare. They move way too fast. So like, okay, well, maybe we'll build the latest and then try and get that to jam that into CentOS. And it turns out that didn't work very well either. And finally, what we realized is the version in Fedora Rawhide is either latest or latest -1. And somebody, somewhere in the magical in the magical world of Red Hat, has done all the work to take this, package it up, and make it look Red Hat-y. And like, that saves us a lot of time. So we grabbed the Fedora Rawhide version, and it took like a 7-line patch to make that build in CentOS 7. I mean, it was a spec file patch. We didn't even have to write code. And so we took that and we backported that along with the 9 or 10 dependencies. And all of a sudden, we were running latest and greatest systemd on Cent 7. Well, that was cool. And then we started looking at adding features, fixing bugs, blah, blah, blah. And so we flew out to systemdconf in Berlin in October, I think. Davida, another coworker of mine, and Zeal, another coworker of mine, and I. And Davida gave a talk on how we were engaging with systemd and like what we were doing in this backport and blah, blah, blah. And everyone's like, that's awesome. We want that. Can you give us that? Sure. So we made a GitHub repo, and we stuck these patches and these spec files out on GitHub. And one of the packagers of systemd in RHEL actually built a copper repo, and you can now not just look at the patches, you can actually go install these RPMs that somebody at Red Hat has actually built and installed on CentOS 7. So like, there's this huge benefit for the community that we didn't even expect to have. We just thought we were in a weird corner, and a room full of systemd people were like, yes, that is awesome, please give it to us. So that went really well. And our speed is the latest release, right? Finding the right speed there was critical. Now we have cgroup. mkosi is a fun one. That's this thing they built to build a system image with systemd in it and fire it off in a container using systemd nspawn, which is how they do all of their testing. And because we were engaged with the community as opposed to being off in our own world, and we were discussing with them what we were going to do on the mailing list and going to conferences and stuff, we were able to leverage this not just for our systemd development, but for a bunch of other internal testing that we do. So that was really nice. There's other examples. I mentioned earlier that there was a fortuitous happenstance. So we were at systemdconf in Berlin, and we were discussing with the systemd packagers for RHEL some of the stuff. And somewhere the conversation moves, and I said something about wanting to fix some things in network scripts. And the guy looks at me and he goes, I'm the maintainer for network scripts. I was like, oh, okay, neat. And so we started talking about all the things we want to do and all these weird workarounds that we have internally. And within like an hour, he had moved the entire code base from some internal Fedora project-y thing to GitHub and made Davida and I maintainers. Fortuitous happenstance. It's awesome. So I sat down and I was like, sweet, I'm going to take all these weird workarounds and make them awesome features and bug fixes and contribute them all up. This is going to be amazing. And I VI'd the file, and it was a mix of tabs and spaces. And I wanted to cry. So I immediately sat down in a bar in Berlin to start rewhite spacing the entire code base, and I did. And I was about to send that pull request, and I went, oh, that's not going to go well. I'm going to be that guy. I'm totally going to look like that guy who's just trying to get a GitHub credit by rewhite spacing your fucking project. Guys just met me. Like, it's terrible. So I sent them an email, and I was like, hey, I'd really like to contribute all this stuff, but, like, no. Like, I can't. Like, can I please send you a pull request to rewrite space your entire project? And there was, like, a brief discussion, and they were like, yeah, sure, go for it. And so I did. I sent them a pull request for rewrite space the whole thing. They were cool about it. And then I was able to contribute a bunch of V6 features, some V6 bug fixes, and per device routes, which is a thing that we had needed for a long time, unblocked several internal projects and is now available in Fedora and which I think will be in RHEL 7.4. So that was like one of those really cool engagements where we just happened to solve this other problem completely unrelated to the thing that we were solving. And I think it's a really good example of what I was talking about earlier, providing context. If I just sent a pull request that touched every single line of their code but made no functional changes, I imagine they would have been a little unhappy. RPM, Yum, and DNF is another one that we're just starting this engagement, but we met with them in DevConf in Brno. We have a couple of patches that we're trying to test and write internally. We contributed a BitTorrent plugin for Yum. We want to make sure that we can contribute that to DNF. We have some rpmdb scaling issues we're working with them on, so this has so far been a really good engagement as well. So that was our journey. Those are the things, the people we engage with, the things that they got out of it, the things we got out of it. We learned a couple lessons. In some cases, we just re-remembered lessons. And the first one is to listen first. Like, really and truly, you got a bunch of people who are working really hard, probably for free, maybe not, on something. And walking in and declaring what it is you would like to fix or change doesn't tend to make them feel really good. So listen first. Listen to what it is they're working on. Listen to where it is they'd like to go. Listen to what it is they need in a pull request or a bug fix or a test plan or a unit test. Provide your context. White space is the greatest example I can give of this. Like, what should ostensibly, in most cases, be a complete waste of everyone's time was really, really valuable, but only because I was able to provide that context. Or going to Red Hat. Right? If I had submitted a pull request to like forward port grub1 support into master of Anaconda, I would have been laughed at, right? But we could sit down and say, hey, look, we really need to install CentOS 6, and that requires grub1, and so can we forward port this thing that you deleted to your latest code base, right? It was that conversation that enabled that to happen. Providing that context made a world of difference. I want to point out somewhat tangentially that non-code contributions are also contributions. Figure out before you engage with the community what it is you can provide. It may not always be code. Maybe you're a Python developer and this thing is in SCaLE and you don't have the time to learn SCaLE. Or maybe your team is just oversubscribed and you just don't have the time to develop. Maybe a bunch of things. But that doesn't mean you can't contribute, and having some way to contribute to a project before you do a major engagement is going to be helpful. Maybe that's money. Maybe you can just donate money or hardware, or time on the mailing list, or time in IRC to answer questions, or documentation fixes. Nobody likes writing documentation, but we all need it, right? There's a million ways that you may be able to contribute to this project. Even if you're a developer, it may not be code. Maybe you have a place where they can test something that they don't get to test very often, and you say, okay, I'm just going to take on testing this for you every 2 weeks. I'm just going to run this on my foobar thing that you guys don't have access to. One of the things that we tend to provide to open source communities we engage with is, hey, we can test things at scale. So like, I don't care if I lose 1,000 machines. If you have some really crazy thing you want to test, like, give it to me. I'll throw it on 1,000 machines and I'll let you know what happens. Right? That's a thing we can provide that doesn't take me much time or effort that not everyone else can provide. Let's figure out what it is that you can provide. You don't have to take a photo of this. My slides will be available, but this is the URL to basically everything I mentioned, the blog post by the kernel team, all of the chef tooling, the systemd talk that my coworker gave, links to a bunch of the projects that I mentioned, our systemd backport, all of that sort of stuff. And I know that we're right at the end of time, but I'm happy to stay and answer questions. And that's all. Are there questions? I'm just that good. Going once. Going twice. All right. I'll repeat the question for everyone, but before I do, I want a clarification. Maturity curve of their project or maturity curve of Facebook? Okay. So the question was, is there a difference, or do I think there's a difference in terms of the project, the maturity curve of various projects as to whether we engaged early, like we did with Chef, versus not engaging and forking as we did with HBase? It's an interesting question, and I wasn't involved in the data infrastructure side, so I don't know for sure. However, my suspicion is it was more to do with the team at hand and the maturity curve of that team internal to Facebook than it was anything else. Because, frankly, I think that they could have engaged with that team, but it takes a certain level of maturity and understanding of the open source community. And one of my favorite things about Facebook, as with all features of anything, there's good and bad, but one of my favorite features of Facebook as a company is that each team is very empowered to make their own decisions. And so while we have an open source ethos and while we have an open source team, at the end of the day, for example, I've worked at companies that say, okay, every project must have 90% unit test coverage, right? At Facebook, we don't have these rules. It is expected for you to go, oh, I'm writing this really core critical piece of infrastructure, I better have a lot of unit tests, or I'm writing the weird widget on the front end that like is going to be replaced 3 times a week, so writing a unit test is literally a waste of my time. Right? And so you're empowered as a team to make those decisions, and if you make poor decisions, you're going to end up in our no blame postmortem, which we call sev review, and eventually you're going to change your mind, or someone's going to encourage you to change your mind. While I think that is absolutely the best thing about, one of the best things about the company in terms of culture and in terms of really empowering engineers, there is the downside that like sometimes you have a team that just doesn't know that they don't know the thing, right? Like there's people talking about known unknowns and unknown unknowns, right? And so I think this is one of those cases where they didn't know the thing. They just didn't have the maturity within the community and within Facebook, and no one caught it until it was too late. And then once you're far enough, like it becomes much harder to justify the cost of remerging until there's something else there, and finally somebody was able to show the value of investing deeply in moving back to the upstream version. So again, take that with a grain of salt. I wasn't there, but that would be my suspicion. Any other questions? Going once? Going twice? Thank you guys so much for coming. keep to the system.
My
Check, check. Okay, good. All right. So, is there a control up here to switch this over to? Oh, good. Looks like it's being done. Okay, well, while that pops up, question mark, I will walk you through who I am. My name is Ryan Sipes. I'm the community manager at System 76. We make computers that are born to run Linux, and that means that we have a whole team of engineers who spend a lot of time making sure that the hardware is well supported in Linux. We ship specifically Ubuntu, and so we typically work really close with the Ubuntu guys in the Canonical team in order to enable and patch what we need to do in order for you to just take that machine out of the box and have a pretty damn flawless experience. The idea is when you get a machine and it comes to you in that nice package and you open it up and you start it up, that you're not worried about whether the wireless works or whether the trackpad works correctly or whether airplane mode works. It all just works. And we support it throughout the lifetime of the product, and so that means that as long as people are using it, we're doing what we can to make sure that everything continues to work and that updates, you can upgrade your system without worrying about breaking something or losing support for something. And that's really, really important for the adoption of Linux. And we're very happy to have been doing this for 11 years. And I'm very happy to share with you the hard lessons that we've learned so that you can avoid those lessons yourselves if you want to produce products built around Linux. Okay, sure. That is perfectly fine. I can change over to VGA if I need to. I have a VGA port on the other side. Okay. It wouldn't be a Linux talk, or it wouldn't be a computer talk, period, if everything just instantly worked. Oh, yeah. Helps if I try to put the port in the right way. And what's your name? Philip. Thank you for helping me, Philip. Yep. So I'm really, really good at just talking out of my ass when there's nothing happening. How many of you have heard about System 76? Everybody, except for this guy. Oh, no, you have heard about System 76. How many of you own a System 76 machine or have owned a System 76 machine? One of you. Shame on all of you. Yeah. So hardware is hard. Before I joined System 76, I worked on a project called Mycroft. We were working on essentially an open source Alexa or open source Amazon Echo, and we went into it a little blind. In theory, we were like, hardware, yeah, that's a computer. You know, we can get the parts, we can put them in this enclosure, and it's just going to be easy, and we're just going to then take those things, put them in a box, and mail them to a customer. Turns out that that is not at all how making hardware works. It's actually a really intensive process, and sometimes you get hardware, and the best priced hardware doesn't necessarily have the software support that's needed, and so that's when you get to delve into Linux land and work with people making kernel modules or trying to get your stuff into the mainland kernel, or sometimes you just have to write other pieces of software to act as kind of middleware in order to do interesting things. And that was a fantastic learning experience. And while I was doing that, I was talking to Carl, who's the CEO over at System 76, and he was walking me. He was my sounding board for this is really hard. How do we do this? And fortunately, he's been working with, you know, parts manufacturers and ODMs and the whole gamut for years and years and years, so he always had fantastic feedback. So when I left Mycroft, I was like, well, I still am really interested in making hardware, so I decided that I would try to see if I could find a home over at System 76, and I was able to. So now I live in wonderful Denver, which is like 38 degrees right now, or it's very cold. We got off the plane and it was like 70 here, and I was like, yes, it's the warmest 38 can be, and it's also very pretty. So it makes up for it in just natural, you know, beauty. Yeah, actually, if you're ever in Denver and you want to see where we work, we have an office that is right in the middle of downtown. It's on 16th Street Mall, and it's like you go down 16th Street Mall. Very good. You go down 16th Street Mall, or you go up 16th Street Mall, and I think that we're pretty much right there in the middle. We're on 16th and Champa, and it is awesome. Like there's everything there. But talking about mass transit, we all take mass transit to get downtown, take the train or the bus. I was really excited there. We had something up on screen. Resolution. I'm not too worried about. There we go. That's good enough. That's the presentation. So, thanks guys. Thanks a bunch for getting that working. Maybe. Can I dim the front lights, guys? Okay. So, when I submitted the talk, we were 10 years in. I'm giving the talk and we're now 11 years in. So I decided to add a little subtitle there. So this is lessons from 10 years making machines born to run Linux, but actually it's 11 years. And, okay, good. So this is Carl. He's our CEO. That's him in his basement. This is the only picture that exists from the first 6 years of System 76. He said he was too busy to take pictures, and so his wife took this picture. That is System 76 headquarters back in back at our inception, which was Carl's basement, and yeah. Well, I've got a there's like an adapter for an adapter. So yeah. Okay. I'm just gonna try really hard not to touch it. So that is actually was taken during one of the binges. He was working on the audio DAC drivers for this was called the Darter back in the day. And that's that laptop right there. It kind of dates itself based on the monitor next to the laptop. That is a nice CRT monitor. He's got a phone right here, a little handheld receiver for his landline phone. That cat's dead now. But yeah, and he doesn't have any gray hairs in this picture. So this is where we started. He told a story about how the website would sell not just Linux laptops and desktops, but actually things that worked with Linux. So printers that were known to work with Linux, other components that were known to work with Linux. And so the first machine that we sold was a printer. So he sends it off. He's very proud. He puts it in the box. He sends it with DHL, and the customer calls 2 weeks later and says, "I never got the printer." And so he goes through a process. Printer gets returned to him, and it's completely destroyed. It looks like the box was just tossed around for days and days and days, and the printer is completely shattered. The second machine he sold was to somebody who was in Denver. So he's like, I'm going to do something really neat. I'm going to go and personally drop off this computer. So he gets there, he walks up, and he's like, knocks on the door. A guy opens the door, and he says, "Hi, I'm Carl from System 76. Here's your computer." And it wasn't the guy who ordered the computer. The guy who ordered the computer was like a 13-year-old kid. It was his dad. And he's like, I don't know anything about this, thanks. And so that's how it was for a time. Outside of that, the community was generally interested in what he was doing. Back then, the Ubuntu community was still fairly small. This was in 2006. And the response was generally good. But we almost didn't ship Ubuntu. When my display comes back, it will show branding for another distribution called Yoper. Has anybody ever heard of Yoper? Before I talked to him, I hadn't either. But it was a distribution that ran KDE and was really, user-friendly at the time. And that's all I really want to say about it. I'm glad we didn't ship it because that obviously was not the successful distro. It's been dead for quite some time, just like that cat. And if I get this back, I'll show you guys a screenshot. I'm not sure why. It looks like it's fairly well seated in here. Not going to sleep. The last 2 times it just jiggled it a lot. It's come back. I want you to know that this is not a limitation of the hardware. Okay, I just won't move, period. And maybe that will help. So this is Yoper. There's the only logo I could find. And I was going to clean it up so that there wasn't the white stuff around it. But then I decided it wasn't worth it for one slide for like 2 minutes. On the other side, you see KDE. I don't know what version of KDE that is. I remember using that version, but I have no idea what version that is. So this is our website back in 2006. The idea became an idea in 2004, but it wasn't put into effect until 2006. Carl started the business with a buddy of his, a co-founder, and the co-founder designed the website. Not terrible by the standards of the day, but now it kind of looks atrocious. At the top, there's a little asterisk that says Linux rules. That's because down there in the corner of the website, there's an asterisk further up on the page that says something about Linux. It says computers to change your world for business, education, and life, with a little asterisk next to it. And then in the corner of the page, it says asterisk Linux rules. On the right-hand side of the page, there's a few little key points that it calls out. It says, what is open source? How can Linux benefit you? What software is included? And view screenshots. At the time, he said that advocacy was really important. He said that a lot of people who were coming over were generally interested in technology in general, and were curious about Linux. And but a pretty high percentage of them was still in the process of learning about Linux. And so it was helpful to try to give a high-level view on what separated Linux, why it was different than Windows. And so he had to do a lot of advocacy, the whole team did back then, to be able to talk people through considering Linux as a platform and actually buying a machine with Linux preloaded on it. Up at the top, there's notebooks, desktops, media centers, servers, portable devices, monitors and TVs, printers, and software available for purchase on the website. We narrowed the scope a lot. Like I said, the idea at one point was Linux compatible machines, and now that has come in a lot, which has also allowed us to grow fairly quickly. The community back then was much smaller. We had a direct line to everybody working on Ubuntu, and we used to do stuff like this. This was a flyer for, this is not doing it for me, guys. I should have just grabbed another. Here we go. You get to see live troubleshooting. All right, let's see if that comes up here in a second. I'm going to go into my system settings here. I'm going to go into displays. Hey, Luis. A button? Okay. Yeah. Sure. So I'll just walk through the slides, and then if we get them back, then we'll talk about them. So when we started, the team was really small, but that was okay. It was really easy to interface with people working on the projects. You know, when Ubuntu's 18 people total, or however many they started with, it's really easy to just tap them in our IRC and say, hey, we're looking at a driver issue, or we're looking at, you know, an issue where wireless is funky, and get a pretty quick response. They grew and we grew. Now it's a much more planned process, going from here's an idea to it's in Ubuntu, which means that we've had to build in a lot of processes around things that we want to implement. The thing that is interesting about this is that back then, though, everyone had to wear a ton of hats. Being in this room with people who work with technology, you'll probably understand that quite a lot. The sysadmin always ends up wearing lots and lots and lots of hats, and knowing a little bit about everything. And so we have a culture that has been built on guys who are Swiss Army knives, you know, who know a little bit of everything. And so the thing that is great about that is that we have folks who are an engineer, a marketing person, and a community manager. That's me. And so that's really awesome when we come to events like this, because most of the team has gone through this thing of being on the support call at one point and then working on a driver issue the next minute, and then finally coming up with a marketing plan and implementing that. So we've grown quite a bit, but we have a lot of experience across the board, which is really just a fantastic asset to have just walking around the office. The other thing is that we're all the nerdiest people that you'll ever meet. We had a thing called Superfan not too long ago where we flew people in to the office and these were people who were doing interesting stuff with our machines. And what we did was we brought them in, we showed them products that are not yet released, and got their feedback on it. But the most interesting thing was we went out to lunch, and the entire lunch turned into a conversation about which Star Trek movie is the best Star Trek. So we like to think that we are our customers, and that puts us in touch with them on a level that a lot of companies just aren't. Everyone who works there uses Linux full time and has for years and years and years, and that makes us uniquely qualified to advocate for Linux and for our customers when interacting with the projects that we do, like Ubuntu and Linux proper. I'm going to go back to HMI because I had a much better experience with that, even though it was going in and out. You can't see it, but we have a key on our laptops that no one else has. And that key is in place of the Windows key. It's an Ubuntu key. If you want lessons about how to run a hardware company, it's to be true to your product and be true to what that product is. We do not like the XPS 13 Ubuntu edition. An edition means that it's not the original intent of the project. So there are a lot of Windows first laptops out there that are held up as standard bearers for running Linux. That is not the way that we wanted to do it. We only ship Ubuntu on our machines, and that is all that we will ever ship, unless Ubuntu as a project disappears entirely, and then we'll ship a different Linux distribution. But everything is built around that process. And so the idea is that that the button on the laptop does what's on the button. So when you press the Ubuntu key, it opens up the launcher, which if you use Ubuntu, that corresponds with the icon for the launcher. This was breakthrough for us. This was much bigger than we would have ever expected. Customers were genuinely impressed that we were shipping machines with a different key that reflected what they were running on the machine. That is really interesting because it says to them, we care about this, and we're there with you. That's a big deal. It reflects what our values are. It reflects that we care about open source, and we're not just going to rebadge a laptop. We're going to actually change it. We're going to create something that has your values. Marketing open source is a totally different story entirely. We've recently, open source solutions are permeating the mainstream in a way that I could have never imagined back in 2004 when I started using Linux. It's crazy. When I first got my first sysadmin job, I worked at a data center, and we were a nearly complete Microsoft shop. There were only 2 machines that were running Linux. They were running Red Hat, and they were in the back. And it was a mail server and a web server. And that same data center, if you go back now, it's totally flipped. There are like 2 Windows machines that are there for legacy software, and eventually they'll probably be moved to virtual machines. The rest of the data center is CentOS for the most part, and some Ubuntu. At the beginning, there were so many questions to answer. So many questions. Now, even people on the street, if I explain to them what I do, now granted I'm in Denver, which there are quite a few engineers in there, but when we start talking, I say, hey, they say, what do you do? I say, I make computers. Well, System 76, what computers do you make? I was like, computers that run Linux. They run Ubuntu. And the recognition has changed dramatically. A lot of folks have these terms somewhere in their head. They've run across them somewhere in their daily life. And that makes our job a lot easier because we don't see ourselves as apologists anymore. We say, hey, we make computers that are better. And that's borne out to be true. If you were here during the UbuCon, Carl talked about how he got 2 calls in the same day. One guy who said, hey, he's a young guy, 24, I think. He was a sysadmin. He says, hey, I love what you guys do. It's too bad this will never catch on mainstream. The next call was a 73-year-old man. He said, this is the first computer I've ever owned. It's excellent. I hope it's also, the last computer I ever owned, which is a little macabre, but we have so many users across the entire gamut who came to the platform simply because they are actually think it's a better product, and it is. Oftentimes I'll hear people apologize for things on Linux as if Windows and Mac don't have any problems. And so when I was setting up my grandfather, what finally put the nail in the coffin on this to where I stopped apologizing for Linux was I tried to add a printer in Windows. And it was this, I used to be, a sysadmin. I used to support a lot of Windows workstations, but it was like so frustrating for this to be the modern state of Windows. Windows 10, it's like, oh, we'll find the driver for you. Okay, that sounds great. Oh, we didn't find the driver. Select from this long list of printers. First start by selecting the type of printer that you have, and then select the model. So I was like, okay, well, that's fine. Brother, scroll down, scroll down, scroll down. Why is there not a search feature? Scroll down, scroll down, scroll down. It's like 1760 DN, 1780 DN. I have a 1770. Like, what happened? And then, so I go to the website, and first I just type in the driver, or the name of the printer and driver, and I get 18 websites that are not Brother, but they're like, download the driver here. I'm like, oh, I'm not going to do that. And so I finally find that, and it's in some way off page, and then it's like, Windows 10 is not supported yet. So I just set him up with an Ubuntu machine a while back, about 3 months ago. I clicked on the little Ubuntu key. I typed in printers. It brought up a nice little add button. I hit add. I click the printer in the network like printers list, and it found the driver. Printer's done. And so that's a sign of a superior product. It truly is. There's some other things. There's barely any bit rot on Linux, and it's just a fantastic experience, especially for those who are doing your average everyday computing. Go ahead, I'll take a question. A new printer and a new driver? Well, it's reliant on, it may have changed, but mainline Ubuntu is reliant on cups. And so is that right? Still the case? Does anybody know? It's yeah. So it actually does a search for those drivers from a list, and you can actually go and look. I can't remember the website. It might just be the CUPS project website, and they keep a list and they just add the drivers to that list, and so it pulls like it would any other software from a repo, and pulls down the appropriate driver. Mhm. Uh, it's it's likely that you'll find it. Obviously, I can't speak to every printer. Yeah, yeah, yeah. So I can't speak to the cycle for every printer because it relies on the manufacturer to make a Linux driver, and so the generic Linux driver for printers usually works with 90% of printers. I've used it on printers that don't yet have a Linux driver, and it works okay. It depends. Your multifunction printers have a lot of extra features that are built on top of that. So sometimes the generic driver will work, but it won't recognize some features of the printer. So so just like in Windows or just like in Mac used to have this problem. You're reliant on the manufacturer to contribute to the platform that you're using. I would say that I personally have never run into a printer that didn't work with the generic driver, but it is not exhaustive, and I can't account for every single use case in every single printer. So I hope that answers your question. Yeah. Yeah, they do. It's their project, or was. I think may have a different foundation. Yeah. So the marketing open source has become much easier, and the difference between platforms has closed. A lot of that is web. Web is a lot more dominant of a platform than it was 10 years ago. For instance, you have tons of Electron apps now, like Slack and like Telegram. These are leading applications that are packaging essentially versions of their website that can, in multiple cases, be used offline, but you still have access to all those features. Like the new Skype Alpha is an Electron app. And so that has really made it easier to convert users and for users to stay on the platform. Application availability used to be an enormous problem. One thing that we're really prideful about is our culture. And if my slides are working, we have a picture of one of our operations manager is this older Swedish man, and he always has a very stern look on his face. And so when he wasn't paying attention, we snapped a picture of his stern look and printed out giant heads. Then we put them on popsicle sticks, and we hold them up over our own faces. And one time we invited him to a meeting, and we were all standing there with the faces held up over our own. We try to be an accessible, transparent company. We try to emulate the open source community in this respect, and try to make sure that it doesn't seem like there's very many barriers between us and our users and the other communities who we work with. And so in order to achieve that, we try to make sure that we're available where people expect us to be available. It's kind of interesting because we have an IRC channel and a Telegram channel. And it's confusing, but I guess I understand it if you're thinking about Dell or HP. people hop in there and they ask a question about System 76, and then a System 76 employee answers them, and then they're like, well, what's your source? And it's like, well, I'm the guy who's working on that. And I found that customers are really, really surprised about that, but that's because we don't put up barriers between who can talk to customers and who cannot. All of our employees can say whatever they want to our customers. There's no real point in putting up these artificial barriers, and as a result, to your question earlier, many of our customers will ask us directly on social media or questions like yours, and they'll answer it to the best of their ability or refer them to somebody who has a more exhaustive knowledge of the topic. I've seen more and more companies going this way. Red Hat has tried to move towards this, what they call the open organization model. I think when you're shipping open source software, it's very important to reflect the values of the community, because ultimately those are the people you have to work with every day to ship your product out the door. And that community does not reward a closed culture. It's just a matter of fact. In fact, any time that we have a closed process, I call them frenemies. People who follow us, but are very, very quick to call out when we're doing something that they don't like. They tell us, and it's very important to not let your ego get in the way and just listen to what they're saying and see if it's actually a worthwhile concept. And so point is when you're building an open source company, culture is key. This slide is a screenshot from our Slack channel, but I'll just read it, and I think it'll work just as good. Someone says in the Slack channel, hey guys. Someone says, hey, what's up? April, one of our support technicians who started the conversation thread, says, did you hear about the space bar? And Cass says, okay. And she says, the drinks are great. And he says, oh no, terrible joke incoming. But the atmosphere is terrible. And then someone says, I heard they're out of this world. And then it shows like 3 people quitting that Slack channel. I don't really have anything to add to that. I just think it's important that you guys knew that. So, engaging community. I touched on this briefly. How many of you actually work on an open source software project for your day job? Man, that's kind of sad. 2. We try to make sure that when it comes to the community that like I said, we're as transparent as possible. We try to go to where people are getting their information. So if we want to tell you about a new product or a new initiative that we're taking on, we might post about it on Reddit. We might go on a podcast, one of the Linux podcasts, and talk about what we're doing. In the picture on the slides, there's a picture of the Linux Action Show guys reviewing our laptops. That has been fantastic for us. It's funny because a lot of folks talk about how small the Linux community is. We now, it looks like, have maybe 3% of desktop computing market share based on net market share, and I can't remember the other one off the top of my head, but so they went ahead and they put those two together, and they're like, we're approaching 3%, and then Windows users laugh about it. 3% is a whole hell of a lot, actually. The Linux Action Show has monthly 200,000 listeners, unique downloads. Take what you will. But that results in a lot of customers who buy our machines and say, I heard about you on this podcast. And I think that is crazy. I think that the reach of some of our own community members is actually just incredible. And it continues to grow. We see with the result of like Edward Snowden and privacy becoming more of a concept that we talk about in the mainstream media, we have more and more people asking questions about Linux and asking us about Linux and asking, okay, well, I heard about this Tails thing, you know, the distribution that does not save anything beyond your session. And we get calls from journalists who say, I found your website, you know, I've started using Tails. Will this work well with the hardware? And so as we engage with these different communities, with privacy communities, with, you know, podcasters, with Reddit, we're finding that results in a lot of great traction. It also just helps raise awareness about who we are and what we do and the importance of what we're doing. And then I have a few Reddit posts in here. I really wish this worked. And they just show us answering questions on Reddit and doing it very detailed. We have Cassidy, who works on the Elementary project. Anybody know what Elementary OS is? He is their designer, and he is to be envied because he has the vigilance to stay up on top of Reddit posts about System 76, which is something that will crush your soul if you do it long enough. So I respect him for his ability to engage in answering the same questions on Reddit over and over and over. The next slide is us wearing medieval garb. We try to engage our community in person as well. That's why I'm here. We think it's important to get down and talk to people one-on-one and be an active contributor to the community. And so I'm hoping, even though I'm also kind of giving you guys a sales pitch, I'm hoping that by being here, by taking questions, by being available, that you'll be able to learn from me and I'll be able to ultimately learn from you. And that's really, really important. And that's why over the last 2 years, we've worked really, really hard to be at conferences, be available, it's costly, but the feedback we get and the information we're able to share, we think is invaluable. And we're wearing medieval garb because the event was our Superfan event and the theme was Dungeons and Dragons. And it's working. That outreach is working. Who has heard of This Week in Tech? Twit. Leo owns an Oryx Pro. And it was funny because he was in the middle of his show, and they have a little chat, you know, that they watch and engage in during the show. And Linux users, salt of the world, we really are, but we also sometimes are idiots. He's a new Linux user. I mean, he's tried it before, but like he gets an Oryx Pro and he's using it and he's like, oh, I want to try some other distributions. What should I try? And they're like, Arch, Gentoo. And so halfway through doing his distro hop to Arch, we get a message from someone who's like, hey, I'm watching This Week in Tech, and he's moving over to Arch on his Oryx Pro system. And we're like, oh, no. Like, if he can move to Arch, we would prefer that he not encounter all the problems learning Arch while on a stream with a Oryx Pro. And so we hop over there, and we didn't try to change his mind. We just were trying really, really hard to engage him and say, like, no, this is how you do that in Arch. Like, and ultimately he's now on Arch, but he has a working stable system. Our drivers happen to be in the AUR, which when I say drivers, I mean all of our patches that we include in our repo that we ship on our machines before they get pulled into upstream. I call it staging because we can't obviously, so we do things to fix the machines. Like for instance, like Ubuntu had a bug where airplane mode didn't work on some models. The airplane mode hotkey didn't work on some models of laptop. We caught it in staging. We were in Ubuntu staging. We were able to include a patch so that our users never saw that. But we do submit those upstream, but we hold them in our own repo until the maintainer accepts that change. And so when I say the System76 driver, that's what I'm talking about. This is not some crazy, driver for some obscure piece of hardware that we write. So point is that it pays off this constant, engaging the community. We get people like Leo to be a great advocate for our brand and for open source in general, and I think that's so powerful. If in 2004 or 2005 you had told me that a mainstream press, tech guy would be using a machine that was designed to run Linux, I would have laughed at you. So I can't even believe some days when I wake up that we are where we are. The other thing is we've started bringing folks into our organization and letting them help us with stuff. One thing is our knowledge base. We've gotten lots and lots and lots of folks who ask, the same questions. It's every time you get a new machine, you're asking the same questions, or maybe you're trying out Ubuntu for the first time. There's a lot of the same questions. So what we did was we were writing all these knowledge articles ourselves, and then we were like, well, what if we just drop this on GitHub? And our entire docs site is on GitHub, and our users can write docs that they find useful or nuggets that they came up with, and then that's our support. I mean, not all of our support, but I have a problem. I'm not ready to talk to a support technician. I wonder if I can figure this out on my own support. So some of those just include things like, I want to install a different distribution on my System76 laptop. Will everything work? Well, we can't test every distribution on our own, partially because we don't even know about some sometimes. Even though we are constantly in that world, we'll get something like, well, how does Hannah Montana Linux work on this? Well, yeah, it is. It's actually a Wayland test environment. I just learned that. But well, we don't really know. Are you using it? Yeah. It's like, well, how's it working for you? Oh, this or this, and this doesn't work. Well, let's document that, and then let's work together to see if we can figure that out. We have only benefited from bringing our customers in and letting them participate with us on helping to create an ecosystem around our products that is not just a company knowledge base. It's a general knowledge base, and it just happens to be in regards to our hardware. Although there are more and more people who are putting general Linux answers on there, and so we are actually having to overhaul that website so that it's more searchable, more usable for just your general inquiries. The other thing is, as we have more people who are buying our products, we have a lot more opportunities to work with people who we never thought we'd get to work with. NVIDIA, we have direct contacts now. NVIDIA, we're considered an NVIDIA partner. For the last 3 releases of the driver, we have engaged very closely on the Linux driver. Part of that's because we have a lot of users who are doing machine learning on our products, and NVIDIA is very interested in that segment, and so they ask us questions, and then we get to be a sounding board for that. You know, here's what we've heard from our customers. Here's where the driver could be improved, and that is really, really powerful, and it's good for the entire ecosystem. That also, I see a canonicler in the crowd, Sergio, hi. That also has allowed for us to collaborate more with Canonical and have back and forth, and they've actually allowed us to post to their developer blog and talk about the type of things that we're focused on, and kind of transition some of the Ubuntu community to focus on these things with us. We didn't ship a high DPI display for a long time because support was not at a place where we felt comfortable doing that. Finally, we kind of just got tired of not being able to ship a high DPI display, and so we asked Canonical, hey, we would like to improve this before we ship something. Would you like to work with us on this? And a few engineers got peeled off for a couple weeks to help us engage with us and patch things with us so that we felt comfortable like we were at a point that we could ship that hardware. And so as our community grows, we're able to interface with more and more organizations, more and more projects, and really make a difference on a grander scale than we did whenever Carl was in his basement working on that one audio fix for that one machine. And we play the long game. If you were at the talk on Thursday, Carl was talking about how we've begun building a manufacturing plant in Denver. And all of our manufacturing is going to go from, now we have a Taiwanese partner and a partner in San Francisco, and it's this big long circle where we iterate and we iterate and we iterate, and there's lots of differences between us and our Taiwanese partners, and sometimes it's chimney sweeping week and everybody's out of the office over there, and so it takes something that we may have designed already and turns that process from perhaps a 6-month process to an 18-month process. That doesn't really allow us to incorporate our customer feedback as quickly as we'd like to, and so as we started looking at things we could automate in the manufacturing process and started to learn and hire people who were, you know, coming from a hardware background, we started to think, oh, well, actually, this isn't as hard as we thought. Granted, we'll see. But so we've designed a couple of desktops, and we're starting to buy the equipment in order to build those chassis and build this thing we call SnapFit, which is our open source method of putting together a desktop so that it can easily be taken apart quickly. And so we call it SnapFit because everything snaps into place. And so we have always been focused on creating an open ecosystem, and that doesn't just mean software. It means hardware. And so we've been patient, and we've been working towards a goal, and that patience is really starting to pay off. We're very, very patient, Sergio. Very patient. Someday we'll use Unity 8. I still believe. I shouldn't do that to him. He doesn't, as he said, he doesn't even work on that part of the project. I guess this slide is kind of pointless because it's a picture of the SnapFit. But if you would like to see it after this, I will have my laptop down there somewhere, and we can go through the pictures together as a family. All right? Follow your passion. When Carl started the company, nobody was making hardware born to run Linux. We're the largest Linux-only manufacturer on the planet, as far as we know. And he told me this story. It's actually super sad. In the early days, he said, I thought he was joking at first. He said, I used to go down to the river and fish for salmon for food, and I was like, And so I laughed really hard, and he was like, well, I'm not really kidding. You know, the salmon would last, if a salmon would last about 2 or 3 days. And why did he do that? Is because he was doing something he believed in, and he was willing to sacrifice in order to achieve that. And fortunately for him, it paid off because the world changed. And open source and Linux started getting deployed in data centers. People wanted to work on the same platform on their workstation that they deployed to. And so ultimately, we went from doing, you know, maybe $10,000, $20,000, $30,000, $50,000, you know, a month to doing, you know, now tens of millions of dollars a year in revenue. So that has changed in a big way, and that's because he followed his passion, and that's something that we continue to do. Like I said, there's a few elementary guys who work for us, and even though we ship Ubuntu, we're constantly talking to them about what they're working on and how they incorporated certain things, and taking that passion and letting that kind of make its way back into Ubuntu, and also just letting them explore that. You know, we're hosting the Elementary Developer Summit that they're doing, that they raised money for here recently on Kickstarter. It's happening in our office. We're going to be loading up the imaging system with the different versions of Elementary so that they can do their testing really quickly on our machines we have in our lab. And it's important to water and take care of that passion. And so we make sure that as a company that we do that. The final slide is have fun. Just generally, if you're working on open source, have fun doing it because you're one of the luckiest people on the planet. And if you're part of a community, you know, I'm convinced there's nothing better to spend your time on, because open source software is such a great way to move humanity as a whole forward. It's this way of sharing your knowledge with the world and then collaborating with people from all over on a shared vision. And I heard that Linux as a project, and I don't know if this is true, but I like to think it's true before I go to bed, turn out the lights. Linux as a project has the most man hours in it of any project that's ever taken place on the planet. That's pretty significant. There's a ton of companies, there's a ton of individuals contributing to this shared vision of a computing platform that anyone can pull down and use for free, modify and change. That's pretty damn awesome. And so if you're not having fun doing that, then I don't know, there's other things you could do, I suppose. I'm going to go ahead and put my cards out at the end when you guys are on your way out. I'll probably put them on that thing back there. I'm the community manager, like I said at the beginning. I exist to engage with the community. That includes you. You're in this room. You're now part of the community. So if you have any questions that you want to talk about, if you have anything you want to talk about, I mean, I'm pretty open. I won't probably talk to you about, like, you know, really personal issues that you're having in your life. But if you want to talk about technology, I'm all for it. So now I am more than happy to answer any questions. We've got about 10 minutes. I don't know if we're going to get kicked out after that. So I'm willing to hang till somebody yells at me. I was really impressed to add on to that. I had a kid stop by the booth earlier today, and sometimes you hear people say something like, kids nowadays just sitting there playing Xbox or whatever. This kid stopped by and he looked like he was like 7 or 8, and so I walk over, and I guess I didn't know what to expect, so I was being patronizing because 7 or 8-year-old, I wasn't going to give him the whole spiel from beginning to end. But he forced me to, because he started asking questions like, what's NVMe support like? It's like, well, okay, yes, there's great NVMe support on this thing, and I started, walking him through everything. He's like, tons of people came by the booth. And I told him about Thunderbolt 3 support and what that means. I said, this port has Thunderbolt 3 support, and the kid's like, cool, and he's like, I've got an eGPU, and I want to plug it into there and make use of my NVIDIA GTX 1070, and he's like, that sounds great. I'm like, you mean like 9 out of 10 people had no idea what I was talking about, and this kid's just like going through it, and by the end I was like, man, I wish I could hire that guy. So yeah, I can attest to. I really like the idea. One thing that we've tried to do is we've been giving to kids on computers for a long time, and we like the idea of giving them a machine that they can actually change and modify, not a lockdown environment where they don't get to learn about how a computer works. I think as a company, we realize that it's vitally, vitally important for you to not only use the computer as a tool, but understand how a computer works. I call it computing plasticity. It's important, like brain plasticity. It's important for someone to understand the concepts of how to save a file, not just that the floppy disk button is save. Like, you need to understand that there are multiple ways to do this, and there are multiple ways to accomplish this thing on each computing platform, but the concepts are the same. And so that's why I'm super, super hopeful that Luis worked at a school district. I'm super hopeful that even if we can't have like a whole bunch of System 76 labs, that they're able to get a ton of Raspberry Pis in, or some computing platform where they can learn about how computers work. Any other questions or comments or? Okay. Yeah. 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 All of our patches are in a Debian-based repo, and so you can add the repo after the fact and have the patches that we carry before they're accepted upstream. Do it. Yeah, no problem. Help from Dell. Yeah. Yeah. I can tell you that our office does not just comprise Ubuntu users. Sorry, Sergio. We have a wide variety of What's that? That's true, yeah. We have a wide variety of users using different platforms even within our office. And by platforms, I mean distributions. We have a longtime Debian user, and she says, don't touch my Debian. And we have a Arch user. I'm pointing because I'm thinking of the layout of the room. We have an elementary user, and we have an OpenSUSE user. So we have a lot of different distributions represented in the office, and that's why they engage with the communities that they're a part of in order to make sure that these distributions work well. Also, we do things like the backlit keys and changing the color on the Oryx Pro are done in the firmware level, and so regardless of what platform you're on, you'll still be able to change the color of the keys. And we do little tweaks like that in order to make sure that you are able to jump to the platform of your choice in order to do what you need to do. We officially support Ubuntu, but that's because we are able to have those upstream relationships, and we don't spread ourselves too thin, because where do you stop with distributions? There's hundreds and hundreds of distributions out there, and eventually you have to say, hey, we can't possibly test all of these. So. No, we actually order. So our partner who makes our keyboards includes those when the keyboards are made. They are not a sticker. They are actually a distinct key. Hint, hint, nudge, nudge. We have another hardware partner now, and we're going to be releasing some interesting keyboards for our desktops that have the Ubuntu key. So if click, 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 click is the sound you like when you type on your keyboard, you'll be very happy. Any other questions? No? Not at all? By the time we get out of here in, 2 minutes, the expo hall will be closed, so you won't be able to, unfortunately you won't be able to, is it 2:58? Or 1:58? Yeah, okay, well then we're screwed. You won't be able to go and probably check out the machines, although we are here through the rest of the evening, so if you see one of us, we might have them in our backpacks, and we can show you the devices. But also, you can contact us. Our contact information is on our website. You can call and get a human being pretty much right away, and you can ask them to your heart's content about the machines. Like I said, we're pretty transparent, so if you want to know the tech specs of the new machine that we just announced Thursday, we can send you the tech specs. All of our machines have a complete product specification list that includes all of the stuff that's in it, which is super important when you're thinking about putting maybe, God forbid, but FreeBSD on it or something. You need to know that all that stuff will work just fine. To the question over here about printers, I'm not a support tech, but our support techs use Linux every day, and they help our users use Linux and install things like printers and things like that. We do full hardware and software support, which means that we actually support Ubuntu up and down. So if you have a question and you call and it's about Ubuntu, then we will try our damnedest to help you come to a solution. Same goes with other distributions, but we'd say hey, we don't necessarily use this every day, so we'll try our best. As such, if you do have questions like that, I know that those guys are super, super smart, and they will. And somebody was saying the other day about how he just had this ongoing support ticket, and it was not a specific thing. It was just his general inquiry, support ticket that we had open for the past 2 years. And it's just every time he comes up with a question, he just goes to the next line and asks it, and we answer, and that's fine. We're your personal, consider us your personal, computer butlers, and you have a question or you want to know something about, it doesn't matter, the hardware, the software, we'll try our damnedest to stick with you and help you, understand what it is that you want to work with. And beyond that, we always appreciate contributors. So like I said, we have a knowledge base. We have a few projects that we've open sourced ourselves that we use to run our business. So if you're curious, you should check us out at github.com/system76. We have lots and lots of resources and fun projects you can do on the website. We have how to make a completely controlled Christmas light display. We have how to make an augmented reality sandbox using our stuff. And we also have some use cases for just we call them weekend projects, just things you can do with friends, family, children, in order to help them learn about Linux and learn about computing in general. And so I encourage you to check those out and share them with friends and family. So that's it, guys. Feel free to come up afterwards and ask me any questions that you want to. And great seeing you here at SCaLE.
Good job, sir. By the way, Denver rocks. Your beer out there. Yeah. Have you been to the Great American Beer Festival?
No, but I'm aware of it.
You have to go. I went twice. You know, I flew there just for that. And it was the first time in my life I said, I don't want any more beer. I never thought in my life I'd be saying that, but
Yeah, that's that it does not surprise me.
just a quick question too. Do you guys like sell any like bare bone systems? You know, like in other words, like any laptops. I build my own custom desktop, so. But your laptops. Do you like full configuration, SSD drives, and all that kind of stuff? Or?
So what we do is on the configuration. Are you up next here? No. Okay. On the configuration portion of the website, we get pretty granular with what you're able to put into it.
Right.
Bare bones. We have an open hardware warranty that allows you to open up and replace any of the parts of the machine without voiding the warranty, with the exception of the motherboard and display panel.
Obviously,
and so
right,
what that allows you to do is, obviously if you have a 3-year warranty, you can modify it as much as you want,
right.
and not.
And that's a good question too. So in other words, your memory is a bit. Some places now they're
It's
soldering.
Nothing is soldered. Nothing is soldered.
So you can access the hard drive, the memory, no problem on the laptop.
Correct.
That's great.
Correct.
Yeah,
and that is not ever going to change. That is
that's
a specific
wonderful.
thing that we.
Yeah.
That is a core part of who we are, and you should be able to change your wireless card.
It's amazing. You don't want to piss off your users. I can't believe that.
Yeah.
No, that's really
well, we
good.
get rewarded from that too. It's not entirely. There's also a monetary, part to that, because people buy our machines specifically because of stuff like that.
That's cool.
We had a chief of staff for a United States senator, and he's running Windows on our machine, which is
right.
But he bought it specifically because of that. He said,
that's great.
I can't find any place where I can change out my components and not get, essentially slapped on the wrist for it, except for you guys.
Your BIOS, are you using UEFI, or what are you guys doing?
What is it?
I keep hearing there's going to be an open source BIOS. I heard that for the past 5 years.
So
or something like
here's
that.
the deal with that. We work with on our machines that have an Intel BIOS. We work really closely with Intel.
Okay.
We have not used to move to Core Boot or Libre Boot yet, partially because it's just there are some things that aren't implemented well there yet.
Right.
And we walk this line of being open and being having a machine that works, and so we I can't remember if our machines use UEFI, because I know that this is like an ongoing conversation, and I know that it's very easy to toggle it on and off. I don't remember if it comes installed with UEFI enabled.
Right.
Usually they're capable of UEFI, but I know for a while we shipped without it enabled.
Right.
I don't know if we're still doing that.
Okay. I know Ubuntu, they have a sign-in key, and so does the big distros, so they can still get around it. But
Yeah.
It's just
super
easier.
easy to shut it off.
Excellent.
And I'm sure you don't need it because you're asking the questions, but our support techs have walked plenty of people.
Like I said, the Dell, you people don't know the hell I went through with Dell. It was a Fry special, cheap. It's a cheap notebook that if I lose it, I lose it. I don't have my life on there. And that Windows 10 is like, get me out of here. It was just a disaster. Thanks for everything. I'm going to definitely look into your, stuff.
No problem, man. Thanks for asking the question.
Got introduced to you earlier in the week along with 4,000 other people you met today, right?
Yeah.
So I'm sorry I wasn't here today. I meant to be, and I'm extra sorry because we were obviously having some display issues.
Yeah.
But I hope yours appreciate that.
Well, I can talk. I have. Yeah, it was.
Oh yeah, test. Okay.
Oh, it works. All right.
Yeah, I think so. Try not to trip on this again. Cool. All right, everybody. So my name's Ian Iberg. As he mentioned, this talk is about using Union kernels in production today. It's not necessarily like a high-level talk. It's not a what is a Union kernel talk. There's 1,000 videos on YouTube if you're interested in that. Half of them are probably by somebody like me. So if that's what you're learning, you can go to the other Union kernel talk, or you can chill here. If you want to kind of follow along, you can go to github.com/deferpanic/Virgo. It's a little tool that we'll dive into later on in the talk. But real quick, I just wanted to kind of go over some things. If you watched any of the unikernel talks online on YouTube in the past 6 months or so, you might hear phrases like this: unikernels are not here now. Unikernels are not ready for production. This is a reoccurring theme. And my questions to these people that are giving these talks are, have you actually booted a unikernel? The answer is no. And then I would ask some questions of, have you actually compiled the unikernel? The answer would be no. And so then the question is kind of like, do you even engineer? No. And of course, we're at a Linux conference, so why am I talking about unikernels? Well, there's definitely reasons. But in terms of who's using unikernels, this is another kind of question that kind of gets brought up, and a lot of people point their fingers and hand wave and so forth. So just to set the record, we at our company have been using them in production for over a year and a half. But who cares about us? Let's talk about Ericsson. I personally know some of the people over at Ericsson working with unikernels. I know a couple of their lead engineers. I know some of their business line guys that are actually using unikernels in customer-facing products today. Not like yesterday, not in the future, like they're actually using it today. And we actually meet down at their office from time to time for our unikernels meetups. GE is using unikernels. Dell EMC, once again, there's another unikernel talk. It's on Unique that came out of Dell EMC, that colossal of a company now. And then NEC, of course. Now, all these companies, I don't really need to tell you guys, are mega large companies. So if you're talking about like, is this kind of a enterprise interesting thing, I would say the answer is yes. IBM is using unikernels. In fact, we'll get into more people over at IBM that are using them, what they're using them for. Cisco is using them, not just for the NFV stuff, but also web-facing stuff. And web-facing stuff is kind of like what we're primarily interested in. And then there's like a whole bunch of other companies that some of them I can list and some of them I can't list for various reasons. But there's a ton of people actually using them right now. So it's not like, are they ready for me in the future? It's a kind of a bullshit question. And then just to kind of go through another thing real quick, we're going to take a whirlwind tour of debugging unikernels because this is something that gets brought up every now and then. Defer Panic is the company I work at, and if you're a Go programmer, you might notice the two words defer and panic are two keywords from the Go programming language. And so anyways, we had built out a whole Go APM tool 2 years ago to do kind of application performance monitoring on the Go language. And when we built the first Go unikernel, one of the first things that we tried was like, does our APM agent actually work inside the Go unikernel? And the answer was yes. So like, not only are we capturing errors and so forth with full back traces, and also the memory usage, which you can see is fairly low in here, but everything else too. And despite that, GDB, maybe the most famous debugger out there, maybe outside of Microsoft Visual Studio, works perfectly fine to debug unikernels. In fact, these are instructions taken directly from the rump-run GitHub wiki on debugging a Go unikernel using GDB. So that argument's a little bit bullshit. This is IncludeOS's kind of debugging interface. I wouldn't call this debugging, it's more of like a stats monitoring interface. And as you can see, they export all sorts of stuff, everything from memory maps, you can go pointer chasing, to the stack sampling, to logging, like the whole shebang. So this comes out of the box with Include OS. And, just looking at it, you can tell already that there's more than enough to go on here. And then OSV, one of the original unikernel implementations, this is an interface that they support. Now, a lot of their stuff runs through the JVM, right? And so a lot of the stuff that you're looking at is obviously JVM specific. But once again, like, this is a lot of information if you're wanting to debug or, figure out what's going on with that isolated app. Now let's talk security. This one's kind of a pet peeve of mine because everybody likes to throw in their 2 cents about it. And the thing is like some of the arguments are just not well founded, right? So this is a headline taken from 2 weeks ago. University suffers DDoS attack from IoT vending machines. They're basically saying they got owned by a bunch of Twinkies. So like this is a real headline. This isn't like The Onion or anything. I mean, this is a real honest to truth headline from not only 2 weeks ago. And so security obviously it's been a problem, and it's getting worse by the day. And so when people talk about unikernels and IoT, and then they start talking about like Mira botnet and all this sort of stuff, it all starts conflating, and people start throwing around opinions and so forth. But some of the people that throw around opinions about security are not giving well-founded arguments. So if you want to talk about security credentials, they should probably like figure out who they're talking to first. I myself have spoken at numerous security conventions for like the past 15 years. I've worked for multiple security companies, and I've gotten in trouble when I was a teenager for defacing websites and probably making people a little bit older than me lives miserable. So in terms of security credentials, I kind of know what I'm talking about here. One of the big things about unikernels, in my opinion, is not necessarily the attack surface that's small, and this is something that gets banted around a lot. Yes, that's true. It is a lot smaller, but that's like, in my opinion, not the greatest argument out there. To me, it's the fact that you can't just fork a shell every 10 seconds, right? So if I'm an attacker, the very first thing I want to do is pop a shell on your system as fast as I can. Whether it's automated or manual attack, it doesn't really matter. This is like the #1 goal that I have. The fact that I don't even have a shell to pop, let alone a fork system call to use, is a pretty big net negative for me trying to attack your system. Yes, there's shell code that does not spawn shells, but it does other things like add an account to Etsy password. Well, that's kind of useless if you can't get into the system, right? So this is huge in my eyes, because if you can't pop a shell on any random system, it's really hard to mass hack. And why is mass hacking such a big problem? Well, if you can't do that, how do you exactly build a botnet? This is something that doesn't get talked about enough out there. This is such a huge thing. A lot of the automated attacks are what preface these botnets. And so the ability of not being able to pop shells is kind of at the root of this. And unikernels kind of deliver that, from the get-go. So enough about that. Some stuff you might have missed about unikernels in the past year if you're not kind of like in the ecosystem, because if you do see some stuff, it might just be the big headlines like MirageOS releasing version 3 a couple of weeks ago or something like that. But let's run through these real quick. So last year and the year before, we heard a lot of talk about serverless and function as a service and so forth, and a lot of people were talking about like, how would unikernels play into this picture? And that is a question that we kind of like looked into as well, because as you can kind of see, I don't know if you actually can see that, but we spun up like 1,500 of these, in a matter of minutes. Spun them up, spun them down, spun up, spun them down, and yeah, it's probably hard to see that column there, but these are all about 1 megabyte big. They're taking 32 megs of RAM each, and so we were able to just spin and cycle these up and down a lot really fast. And so it's kind of something that you wouldn't be able to necessarily do on the existing public cloud solutions. And even like if you had that OpenStack solution, this is kind of something that we would look at. So this is all, this particular example is running on KVM. but you could theoretically do this with like any hypervisor. Zen particularly has lots of good guarantees on performance in that regard. Some other interesting things that kind of came out last year, guys, our friend Hassan, he's, I mentioned Ericsson was using unikernels, so this is actually over at Ericsson's office at a unikernels meetup we do in San Francisco. And so he actually works for Siri, or not Siri, SRI. SRI spun out of Stanford Research like back in the 60s or 70s. They're responsible for producing Siri, which Apple later bought. Anyway, so really smart dude, right? And his kind of research thing was, we're going to take this arbitrary legacy code, we're going to compile it to LLVM bitcode, and then we're going to do optimizations and analyze that bitcode to produce a really optimized unikernel. And so that's kind of one of his things that he's been working on. Once again, it's not something that gets like advertised about or anything, but it's some really incredibly interesting stuff that's been going on in unikernel land. Another thing, somebody was joking on Twitter, I don't know when this was, I think this is October, looking at the dates. And they're like, Elk, the Elk stack was such a pain in the ass to set up, and this is like some DevOps dude, and then somebody responded to him, he's like, yeah, well, like try running that in a unikernel, and I was like, well, that's interesting, I haven't looked at it, I don't see why it would be a problem, right? But so we went ahead and spun this up, and so this is Elasticsearch running as a unikernel, and there's no code modifications at all. The stuff at the top, the command line parameters and environment parameters, I mean, that's stuff that you would find in a init file in your favorite init system out there, right? So stuff like class path, and Java, of course, abuses the command line arguments. So this is something that's like pretty straightforward, for anybody who's in that domain of the ops world. Another thing that happened, so every now and then I reach out to Derek over at Sarah, and one of his pet projects is Nats. So it's this high performance messaging system written in Go, like super high performance. And I reached out to him. I was like, hey, have you tried any of these unikernels yet? Have you played around with it yet? And he's like, no, but so he signed up, and he immediately tried out Nats. And of course it doesn't work for him right off the bat, right? But what was really interesting, if you look at this code, was it's all of 13 lines of code is what we had to stub out to make Nats work as a unikernel. And the only reason we even had to do this is, if you look, we had to specify a build tag for the unikernel implementation we were using, the rump run. And so it was very minor edits to Nats, and so this is still in the Nats source tree, and you can run Nats as a unikernel. This is the type of real world stuff that people can actually do today. It's not rocket science. You see all the PhDs and stuff talking about unikernels, but this is something that like anybody can spin up and do themselves. Now, okay, speaking of PhDs, these guys are PhDs, but this is also at another unikernels meetup. The two that are talking here, we're talking about doing, get ready for the buzzword heavy stuff, but they were doing blue-green deployments with response diffing with the Diffie project with unikernels. And basically what they were looking to do was do a deployment model similar to Docker and so forth, but without the registry. Since they were so tiny, the artifacts that they were deploying, they were like, you know what, we don't need this middleman of a registry, we can take that out and we can just push our updates that way, and then do these blue-green deploys. And so that's a project that they've been working on for the past like month and a half, 2 months, maybe more. That's why I know of it anyways. Another more recent thing that has come out recently, Dan Williams, I mentioned IBM. People over at IBM have been doing some work with unikernels. Dan Williams is one of those guys. He's responsible in large for the Solo 5 project, which is a new virtual machine monitor for specifically for unikernels. Because Dan's like this one guy, he's like, you know what, if we're throwing out the operating system, let's just throw out this old hypervisor as well. So anyways, basically, really smart dude. And but the gist of this announcement is that he's starting to integrate his Solo 5 project with the native OS X hypervisor API, which is really kick-ass news because the hypervisor situation on OS X sucks. And it's honestly like one of the biggest things for the containerati people out there too. So this is really great news coming down the pipeline. Now let's talk about what sucks. I'll be honest. There's things that do suck, you know, and I'm not gonna just spin bullshit. I'll give you real life examples. So sometime last year, I was like, let's take Postgres and let's turn this into a unikernel. I just want to see like what is the work involved in this. Now, I don't know how much you all know about Postgres or how it works, but I kind of knew going into this project the challenges that lie with this and how they compare and contrast in unikernel land. So I went ahead and downloaded Postgres, and the very first thing I did was look at the number of fork calls, right? So on 9.5.3, which is like August or July of last year, there's about 46 calls there. So all those are going to have to be turned to threads. Like right off the bat, you have to transform all that. So, you know, you put on your headphones, and step one, you just start mass commenting out everything, right? You know, because I'm just trying to boot it. You know, what's the bare minimum to boot this project? Step two, just gratuitous logging, printf debugging everywhere. And then, you know, step three, you know, all these forks, we can just change to threads. The vast majority of unikernel implementations out there allow many threads, but not necessarily multiple processes. And so the pattern is to go from this to this. But that's just the forking, right? Because after you finish that, you notice that the postmaster is one of the first kind of things that it nets in Postgres, and the very first thing it does is sets up shared memory. Well, shared memory only really makes sense if you have multiple processes. Not only that, but if we look at the System 5 IPC stuff, we have shared memory, we got semaphores, we got shared libraries, we got multiple processes, we got signals, we got the forking, we got the IPC. All this crap Postgres uses, and none of this makes sense in unikernel land. Once again, most unikernels are single processes, single address space systems. So I guess the learning on this is basically, if you want to go down this route, it might be easier instead of trying to modify that code. You can maybe potentially split it out. You know, Postgres makes all this use of different systems. Maybe they can each be unikernels. But on this note, there are other systems that don't fork. I think we all know which one I'm talking about. Windows, of course. Now, Windows obviously has support for multiple processes, but it doesn't actually implement the fork. And so when you're diving through Postgres code, you're finding stuff like this: internal fork exec, backend fork exec. And so they've already put wrappers around situations where you have to deal with this. But one of the best things about doing these projects is you do what I call code dumpster diving. And this is a real comment that I stole from this line. Like, you can literally click on this link and see this code. Due to backward compatibility concerns, the replication parameter is a hybrid beast which allows the value to be either Boolean or the string database. And so as a programmer, you're like, this is just some MongoDB bullshit right here. You know, so, but this is the fun part I like with these projects is you run into these little gems. So what else sucks? Well, you know, the operating system, whatever you're using, Ubuntu or OBSD or whatever it is, you know, you're given so much that you take for granted, right? And so one of the things that we kind of ran into that we took for granted was the fact that we just assumed our certs would be in the proper place. We're making outgoing HTTP calls, and those were working, but our TLS certs were complaining about missing X509. Well, it turns out, and so this is the Go runtime, well, the Go language source. It turns out that every single distro out there not only has their certs in a different location, but it's a completely different file name, which is complete batshittery to me. So, you know, we had to go in and modify this for something that really shouldn't exist to begin with. But this is kind of an example of the type of stuff that you might have to deal with. I'm not saying all the time, but you might have to deal with if you want to play in this ecosystem. Here's another kind of sample that sucks. I don't know if anybody recognizes Bob on the left here, but So he talks a lot about testing. Anyway, on the right is an example of a test. We were having a problem with the Go runtime where garbage collection wasn't actually getting ran, and so eventually, like after a certain number of requests, they just stopped responding. And so after the patch was fixed and that was working, we're like, well, we need to write a test. How do we actually go about doing that and make sure that our fix works? And so what we did was we wrote a little sample Go program that it boots up, it prints out GC stats, then it allocates like some big ass array, and then it prints out the GC stats again and makes sure that everything runs. So this happens on every single build that we do with the Go language. And so then it compiles that as a unikernel, boots it up into KVM, it waits a little bit, and then it screen scrapes the output from it to make sure that GC has ran. So this is obviously a complete pain in the ass, and this is totally unwarranted, and this is definitely like one of the shittier parts of the ecosystem. So there's that. Well, I mean, that's a good question. This is one of those things where the tooling could be much better. This is a little bit of an outlier because this is more language specific rather than, like if it was a dynamic language, it would probably work differently. So it's not something that I don't think it's a one size fits all type of solution. So yeah, it's just, I'm just trying to be real with everybody in the room. These are the actual like pain points that might suck. So, but the thing is like, what's a hacker to do, right? We hack around it. It's not a big deal at the end of the day. We run into this stuff using Linux anyways. So enough of that. Let's go ahead and build something. Once again, if you've downloaded this tool, you can kind of follow along. Use this as kind of a teaching tool. GitHub.com/deferredpanic/Virgo. If you download this, you can pull down ready-to-go unikernels in a matter of minutes. Like you can literally boot your first unikernel in 2 minutes on your own machine. If you want to download them versus build them locally, you can grab an account and go for it. Actually, I don't even think you need that. But basically, you can access through this tool ways of running your unikernels locally, and then also kind of going through them. So if we look at a sample project, and it is a project, it's more than just like a raw disk image, right? That's something that if you read some of the tutorials online, they're just hello world tutorials. It's not like a full-blown, this is how you run it type of thing. And I think that's kind of the missing part, is filling in with people who are interested in running these, kind of giving them the tools and the knowledge to kind of create systems for themselves. But if we look at this, we have a project, and this is running locally. We have the kernel, of course, which is the image and probably everything else that you want. Logs, we probably want to interact with it somehow. The PIDs, we're just keeping track of the processes. Now keep in mind, running this locally, you're going to be using like QEMU, or maybe it's VirtualBox or something else. Obviously, Linux is going to be a much better choice for you than OS X. Yeah. We'll get to that. And then we have this manifest and then a set of volumes. So in our experience, once again, contrary to a lot of the hello world tutorials you'll run into out there, we found that having like a single volume on the system is not the most ideal thing in most cases. Typically, we want multiple volumes for lots of different reasons. But in terms of the manifest, you can see kind of a sample manifest that you would find here. So we set the memory to like 64 megs. A lot of this is just arbitrary. The kernel is the kernel name. Multi-boots are not multi-boot. There's some implementations that aren't. They might just be raw disk images. And that does have consequences in terms of, can I pass in environment variables? Can I do other stuff? So it's something to think about. Once again, the command line, the environment variables that you might want to set. And then, of course, your volumes and capacities. Now, you can kind of see that we actually set up 3 volumes for this one. One was for what we kind of do for system-related files. So this is like your SSL, your host file, your like all this crap. Then one's for like here the Python interpreter and everything of that self, and then the third one's for your actual personal project code itself. And so that way, like if you want to change out your new code, we don't have to create, you know, we don't have to just keep on recompiling every single time. We can just upload a new volume with your new code, and it just immediately takes effect. So this is one secret that we kind of found when we were playing with this stuff, and it speeds up development and deploying like tremendously. In terms of building these things, I'm not going to kind of really talk too much about it, but I am going to kind of go over our thought process when it comes to building these, because there's no like set standard, and I don't think there's never going to be like a Docker file type of thing for these things. It's way too different, you know, because you have IoT, you've got NFV, and you got web. We're primarily interested in web, and you would build unikernels for web completely different than you do for NFV. So it's just completely different stuff. But I've kind of divided the dependencies into a couple different layers. So once again, dependencies. So level 1 dependencies are kind of just native libraries that your application uses. You're probably not in the process of dealing with these most of the time. This is like for your DevOps or your sysadmin or whatever is going to come in, apt-get install, or they're going to Ansible, they're going to install Docker, whatever it is, right? There's probably a handful of these libraries that you have to have, and I can tell you right off the bat, libxml, which comes with its own FTP server, by the way, and libxslt is used by almost every single dynamic language out there. So if you're Ruby, your Python, your JavaScript, any of that stuff, you have to have that. And so the way we build our stuff is that we actually have these binaries sitting around, and we just link them in. It saves you the time of compiling them. We know what goes in, their hash, their version, their safe, all that good stuff. So that's level 1. Level 2 is kind of like code-specific stuff that's specific to your project. So this is your bundle install, your npm install, your pip install, like all this sort of stuff. This is dependencies that your project needs, but it's probably specific to that language. So once again, this is kind of different. There's caveats here. So like if you're in Ruby land and you're using RMagic, that actually uses a native library, so you're going to need ImageMagick installed as well. So we've kind of separated those, but in most cases, like if it's Ruby code, it's going to be a Ruby dependency. If it's Python, it's Python, that sort of thing. And so all this is to show you that this is all like automated as hell. Otherwise, there's going to be some ugly bash bullshit. Level 3 is kind of pre and post setup. So like there's typically random stuff that you might need to like shell out before or after you compile your image to do pre-processing or post-processing of your image. So that's, you know, you don't have a great example here, but you get the idea. You can like use apt-get or whatever. And then, you know, we ourselves actually export kind of a compilation system to where we actually have it set up to where you can check in code to GitHub, and then you have a GitHub post commit hook that sends a build trigger to our system, and we immediately compile your unikernel, and if you're actually running them, we'll go ahead and cycle them out and push them to prod. But what I wanted to show you on this was this little script box, which is kind of what I just showed you right here, the script section. There's another command here called the build pack, and the build pack's pretty interesting. Now you can kind of see where it says build pack : Rails. So I don't know if you've ever touched a Rails project, but if you have, you can kind of think about like all the crap that you have to do to make that Rails project run. And you know, you have to pick your Ruby interpreter. Are you running 1.9 or are you running 2.3? You have to pick your Rails version. Is it 2.x, 3.x, 4.x, 5.x? You know, all your dependencies. And so, and this thing goes down to like, is it libMySQL? Is it libPostgres? Is it, you know, what are all your dependencies? And so you think about the tools that you use today and how you provision these systems for your projects today. Well, all that needs to be kind of reinvented and redone. And we kind of have our opinion on how we think things should work. Everybody has opinions. So that's kind of what we think is, you know, make it as simple as possible. So if once again, we're at Linux Talk, so this slide might not be super important, but basically on OS X, there's a few things you need to do to get started to come up to par to a Linux system. You probably are missing your ton and tap devices, which don't come natively in OS X, so you can download these extensions and get them installed. And then the firewall seems to change from release to release. As of last summer, they were using IPFW, and then they switched to PF control. And so that's how you can do your fake NAT translation. Because once again, you guys probably don't have Ethernet on this, and so you're probably using wireless, and you can't really bridge on those devices. Not truly, anyways. So that's something that kind of bites you hiddenly if you're not set up to use those tools immediately. But just to kind of show you an example, here's some nasty little shell code. But it shows you, your config and then your NAT translation for that device. And so this is all inside that tool that you can kind of look at and read to see how we're doing this automatically. And then you get to QEMU, and as if that code wasn't nasty enough, then you look at QEMU's code where they take in JSON as their option parsing. They also export a nice QMP protocol, which you can use there. But here you can attach the block devices and set up your network and point it to the kernel and all that good stuff. And so, like, when you go to the Hello World tutorials online and you're like, how do I boot these things? And people are like, just use QEMU. It's actually not as easy as that. There's a whole bunch of other crap that you want to have if you want push button deploys, for development or prod. Now, I showed you kind of the nasty stuff, but just to show you kind of like what more production-worthy stuff looks like, this is an interface taken from about a year ago from a client tool that we developed. And so you can kind of see, and this already assumed like multi-tenant tenancy on the system versus your development's maybe not guaranteeing that. And so, like I said, this is about a year ago old, but you can kind of see all the different things that it's exporting to that particular client. So you asked about public cloud. So this is opinion. I don't think the public cloud, as it is today, is really, it doesn't gel well with unikernels. There's lots and lots of reasons why. Just to give you background, more than a year ago, so back in January of last year, we were on Google Cloud. Love Google Cloud. It worked great for what we were doing before we wanted to run unikernels. And before that, I had used Amazon since like 06 or something like that. So long time public cloud guy. I'm not like, I've been on the bandwagon. But there's some things that it was meant for Linux. It was not meant for unikernels. Right off the bat, if you try to provision an image, either Google Cloud or Azure or Amazon, right off the bat you run into these 1 gig volume limits. So you're like, well, that's not a big deal. I don't care how expensive it is. And to me, it's not the price issue. It's more of the fact that if I have to compile that image, and I'm probably doing that locally, I don't want to be pushing up this 1 gig image every time I hit the fucking deploy button. And it doesn't matter if it's a sparse file. It's still going to be big because you're using all these different layers of APIs. And so not only is this like the minimum, but the 10 gig is like their, kind of the default. And so that's a huge problem, like right off the bat, for a real production system. The other thing, when I was showing up earlier where we were spinning up like 1,500 VMs all at once, if you were to do that with like T2 nanos on Amazon, that would be a ridiculous bill by the end of the month. And T2 nano, for those of you who don't know, I mean, that's like the cheapest you can find on Amazon. And it's literally like no resources. So it was meant for the old VM world, not for unikernels. Now, eventually, I'm sure they'll add support, but until they do, you're kind of relegated to using other dedicated stuff. So yeah, hell no on the 1 gig. L2 networking, this is another thing that we ran into. Once again, we're not going to go hypervisor. So like, I can't just sit there and run KVM on Google Cloud. There's no hardware acceleration for that. right? Because we're already being hardware accelerated on the underlying VM. Now there is some academics that have, and I think Parallels or something, they actually did nested hypervisor pass-through, but you can't find that on any public cloud, and so that's like you have to compile it down into that base image. Well, then that presents the other problem. So if you're coming from the unique talk, this is actually how they do it, is they actually have another instance that kind of controls their other instances. But that gives you very limited control, and it really suffers because there's a lot of security controls and there's a lot of routing and networking controls that are just, they're not exposed to you. It's not like they aren't present. Zen obviously gives you that capability, but you can't touch it because it's not yours to touch. So this was a big impediment to us for what we wanted to do, so that sucks. And this kind of implies that resource-aware scheduling is just like not even available. So once again, if we're talking from like a serverless point of view, or if we have all these hundreds of unikernels and we want to schedule them in a way that makes even remote sense, we really need to be at that hypervisor layer. And so this was all sorts of stuff that kind of made us like spin off our own stuff. And so after going from like one dedicated provider to the next, we eventually just started like racking our own servers, and so those are in Fremont now. So yeah, that's where it stands there. But at the end of the day, like unikernels share similar problems and similar benefits with containers. They also share similar problems and benefits with VMs, though, and this is something that a lot of people don't immediately recognize. We have 15, 20 years of like kind of enterprise virtualization out in the world today. So we have all this software that's been built up to deal with VMs, and we get to reuse a lot of that versus a lot of the, obviously Bill Joy, did Chroot back in 1979. So the point is that it's a little bit different from all the Docker stuff today. On terms of workflows, unikernels offer lots of different workflows that are not readily apparent, and some of them get forced upon you. One is the configuration management. It's something that people are like, well, they deploy their first unikernel, and they're like, oh, this is cool. Okay, well, let's go port all these systems over, and then the next thing they know, they're talking to the DevOps person. He's like, well, how do I deploy my configuration management? Because once again, most of those tools are using shells and they're SSHing in, or maybe they have an agent sitting on the system and they're yanking down changes or something of that nature, and none of that's available to you. So just as kind of an exercise, I'm not saying this is like a production thing, but as an exercise, just to show you, this is like, and you can find this on our GitHub, it's like a 15-line PHP app. All it does is export a simple little file browser that you can kind of edit and mutate. And so you can kind of see here we're playing with the host file on the system. And so I guess what I'm getting at here is like, just because something seems kind of impossible at first doesn't mean it's impossible. You just have to kind of think about it differently to deal with it. Then one workflow that I actually kind of like is what we're kind of calling the volume deploy workflow. And it gets back to the part where we found that multiple volumes were better for lots of reasons than one single volume, particularly with interpreted languages, because if you're applying the new code, chances are you don't need to update the JavaScript interpreter, chances are you don't need to update the PHP interpreter, all this sort of stuff, because it's just, it's just new code there. So what's really cool is, once again, using PHP as an example, it's like lowest amount of code to illustrate an example. We have this little app, all it says is test, and then it includes this other file, and then it says test, right? So we're missing code here, but all we do is we go ahead and insert, a hello from blah, blah, blah. We make a new file system out of it, and then we upload it, and you can kind of see we just remount that file system, and we're off to the races. So you might be thinking, wow, man, this sounds a little bit eerily like NFS. Yeah, yes and no, but it does allow you to think kind of outside the box in terms of how do I deploy changes and how do I deploy code to these systems, and can I do this in a different way than what I'm used to nowadays. Databases. So once again, this is one of those things in unikernel land where you don't know that this is actually a issue until you actually go try to deploy something, and you're like, well, fuck, how do I actually do that? You know, because most people are probably used to just like they have some script, you know, some rake file or whatever, and it goes and it shells out and does its, you know, MySQL blah blah blah, and you know, all of a sudden you have a new database schema. So you can't do that in unikernel land. So all your code needs to be pushed out into its own image. And so I don't see this necessarily as a bad thing. It's just different. It's very different. So in terms of this is just an example in Go, you know, where we literally deploy like an application. Now this is obviously a bare bone example. So you could imagine somebody makes a tool of this, and then you just have some YAML with your new schema or whatever, and you go to the races like that. But this is kind of the stuff that when you're talking about tooling, this is the type of tooling where we could use more tooling in the ecosystem rather than doing something stupid like this. And then this is something like just something I've been talking to lately. You know, I mentioned all these companies that I know that are working with unikernels, and they all have this kind of like reoccurring theme. They keep on asking me, and they're like, you know, should we be calling these things different? Because it is kind of interesting. Anyways, so the question is, what were you build? And before we get off here, I'll show you the tool. So Virgo is that tool that I kept on mentioning. And can like everybody see that? I can kind of bump it up a little bit. So yeah, so we have this little tool. If you've ever used any of the Docker bullshit, it's very similar on purpose. But basically, you can, you know, look at your images, and we can kind of pick this. Can run this HTML1, and if I can type this bastard, and it'll go ahead and it'll run some stuff. And so now we're deploying. We have an HTML app, so this is just static host, right? But we can also deploy databases and so forth like that. So in that case, we might deploy multiple unikernels working together, one running in a database and one running as a script. And you know, there's plenty of other stuff. So here we're gonna spin up another one. This one's a PHP one, right? And so now we're running a PHP unikernel. But really, the list is endless, as you can kind of see from some of these. I just searched for some test unikernels. So, you know, my friends talked about registry-less unikernels, or registry-less unikernel deployment. We actually do run a registry. I don't necessarily agree with that deployment model, but I do see it as an easy way for people to kind of try things out and kind of get started. And you can literally pull down any of these and run them locally in like a minute. So it gives you some room to play with. I think that's all I have right now, but we can jump into any questions or discussions or arguing that you all want to do. So. Yeah, so that's a good question. I would say, you know, if you took like the average VM size for systems on our site, it's going to be about 20 to 30 megs. Now, having said that, if you're running something like Ruby or Java, those tend to be pretty big. They can be like 200, 300. There's not so much we can do. Those languages take a lot. I'm sorry. Now, if you're doing something like Include OS, so Include OS is a C++ implementation. They produce stuff that's like less than a megabyte. So less than a megabyte. So like in the kilobyte range. I can literally, if we actually have network here, yes. All right, so I can just show you real quick. I think I have some booted up here. Oh. So yeah, so like this Include OS one, I mean it's literally 700K when it boots up, you know, but You know, the Python stuff can be fairly lightweight, and actually there's other interesting things coming out with Python. Like I just saw one the other day that it was specifically built for Raspberry Pi, but I was thinking you can take the exact same thing and use it for what we're doing. And so yeah, so this is kind of an interesting thing. I'm booting an application here. It's actually already booted, but the DNS takes a little bit for that. But yeah, so it really I would say your mileage varies quite a lot in unikernel land, and that's why I don't like really believe in a one size fits all. Depending on what you're doing, what language you're using, what implementation you're using, like all these different, they're so wildly different that I don't even think you can have a different thing. And so like, for example, this is Rails with the database and everything running as a Unity kernel. So if you're talking about like real world applications, the answer is a definitively yes. Different parties are going to have different results. So, but it is, yeah, I mean, you can dream it, you can do it, so. Any other questions? Good. Cool.
I'm Hans. I'm one of the ones who's helping put it on the track. So I was just calling to check in. So we're having problems with the screen again?
I think we just haven't.
Ethernet cable here. Oh, I do, yeah, right here. Okay. Right there, looking at it. Let me find the end that doesn't work.
We'll get started in a second.
Okay.
Said the voice of God.
Get it out of the way now.
It should work cached.
Yeah.
You're giving away all the jokes. Could do F11. Success. So let's see. 1, 2, 3, 4, 5, 6, 7. Over 10, you owe me a beer. Thanks for coming, guys. Last talk of the day. Thank you so much for coming.
6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17.
Absolutely not. That is my beer.
So it's not double. So we have 17 in the audience, and I actually suggested if we had like under 10, maybe we just go get some beers and we make it like a fireside chat. Not exactly.
I think you just said that by coming they blew free beer from you.
I did. So thank you everyone for coming. I'm Christopher Ado.
I'm Clint Byram, and together we're the aristocrats. Oh.
We did have a whole dance routine worked out, but the stage doesn't
Yeah,
have
it's
the
not
room
going to work
for
with
it.
the chairs. We'll next
So
year
we're just,
we'll do
we're
that.
gonna,
Yeah. Good to know. Don't let them anywhere near the stage.
So we're talking about transforming organizations with OpenStack, and the alternate title is The Story of Pirate Cloud.
Yar.
And I'm not sure I licensed that from Lego, so don't tell them.
Oh, yeah, I'm sure they're very nice people in Denmark. They're very happy.
That's true.
So, both of us work for IBM. We used to be on the same team, but recently we've split up. But about a year ago, we were working on the same project called Pirate Cloud, and Chris and I took on this challenge, which he's about to describe to you.
So we came to IBM. He was at HP. I was at Verantis, and we kind of came in with a whole bunch of other people, and we had a very simple challenge, and that challenge was to deploy OpenStack. Show of hands, quick, anyone here, have you deployed OpenStack? Okay, now keep your hands up. Have you deployed it for master? Okay. Continuously? No hands? All the hands went down.
Looking, no.
And without carrying any local patches, or only really basically with carrying absolute emergency local patches. So that was a challenge. It wasn't actually simple, but we were up to it.
Yeah, so, and we had learned a lot from our previous endeavors with OpenStack, you from Verantis, me from HP and others, and we decided we can do this. We've seen the mistakes, we've seen the pitfalls, and so we started the Skunkworks project.
So it was Pirate Cloud. It was, definitely kind of supported by some people, and those people cared about what we were trying to do, and they made sure that we had the support and the money to do all the things we needed to do, but it was also a little bit underground, and we were, it was a proof of concept, and it was, like I say this a bunch of different ways, it was a work in progress. It wasn't production ready. It had some kinks to work out.
As any good project is, right? But definitely it was subversive in that, not in that we were trying to subvert anything important in our business, but we were subverting some of the beliefs that had been built up around OpenStack that it's really hard to deploy, that you can't do it from master, that you need to carry a lot of patches to make it work. In fact, we believed all these things to be opposite of the truth. And so we did kind of feel like we were that pirate radio station, like, you know, we're going to tell you the truth, you know, they can't shut us down. And that's where we came up with the name.
And we had some broader aspirations too. We believed that by setting up this project this way, setting up this cloud this way, in some ways we kind of intentionally tied their hands and made it in a way that would force the internal contributors to increase their upstream involvement, which was one of the key things, was not letting you really carry local patches, make it much easier to fix it upstream first. The other thing, using the same tooling, we believed, get much better collaboration and introduce people to things like Zool and Garrett and other kind of really good, really great.
Or in some cases, Git.
Yes.
Right.
Some people, it was new to a lot of, surprisingly.
And the increase of upstream involvement was probably the most important thing we were chasing there. In that one of the things we had seen fail in OpenStack deployments was that there was this sort of belief like whatever just comes spraying out of OpenStack is going to be perfect and ready to turn into a money-making machine on day one. And that absolutely isn't true, and we know that should be true with any open source project. The people who do the best and build the best businesses on top of them are at least present in the upstream, if not also developing on it. So we wanted to make sure that when we taught these teams working on it, that they understood that it's the right thing to be working out there in the open and in the community. And the best way to do that was basically make it the only thing, which is what we did.
So we had some good reasons, just like Clint was saying, about why deploy from master, which goes along with that. And actually, I'll let you talk about most of this because the next few slides are very much.
Right. So it kind of sounds crazy. Like a lot of us have come up in open source. You know, release early, release often is a thing, but we still wait for the release, right? Like unless you're a crazy pants developer who wants to try all the latest crack, like you wait for the release so the developers at least said it would work. But OpenStack is different, and it has been different from day one in that people were running it from as soon as it existed. People were running whatever was in master. This was Rackspace. This were other companies, and so there's care taken to take care of it. And that combined with the fact that people like Jez Humble, who have basically published what I call, you know, sort of my DevOps Bibles of continuous delivery, where, you know, limiting risk is actually easier if you just deploy a little bit of change each time instead of deploying millions of lines of code, which OpenStack produces every 6 months. And definitely as you are deploying, if you want to change it, if I want to make a patch to OpenStack and do it upstream, if I wait for the 6-month cycle, it might be a year before I can deploy that patch. But if I'm deploying continuously from master, I can go ahead and just land that upstream. 2 or 3 weeks later, it's out in my cloud. So that is a huge benefit. Right. So I included here, this is a graph from our actual deployment when we were deploying. And this is the number of lines of code change that we were deploying every time we went out to production. So when you see this, these are a few days apart. We would try to deploy every Tuesday and Thursday. And we would take all the code that OpenStack had landed, put it into an intermediary step, and try to test it. And if it passed the tests, we would land it in our code. And then on Tuesday or Thursday, we would put it out to production. So this was usually 40,000. There was a big patch that landed, right? So you see up there almost 100,000 lines of change every few days. This is how we were deploying from master. As soon as something went into the OpenStack code base, it went into our cloud. And you can see some of the distances are longer because it failed tests, and we had to spend a few days working upstream or working downstream on patches to fix it. But every day, 40,000, 50,000, a few tens of thousands of lines of code, which seems like a lot, and it's like, oh my God, scary, we're sending this much out. But if we had gone with the stable model, this is the release before Liberty, and then up there is Newton, right? And you see these are, I don't know if you can see the scale, it's really tiny, but that's 4 million. So on release day, we would have to find a way to mitigate the risk of 4 million lines of change. instead of 40,000, right? And then on the next release day, Newton was, or that's actually Liberty, I think this is the one before this, Ice House, or whatever, I'm losing track of the names, is 6 million, right? Huge releases. And then this one actually came out while we were working, because I don't know if you guys noticed, but down there is actually the amount of change we actually we're doing on the same scale, which is almost invisible.
This is an overlay. That
Right,
the
this
blue
is actually
squiggle
the
at the
same
bottom,
graph.
that's
same
the graph
graph.
we were looking at from the previous slide. So, go back. See,
it's
this is-
pretty easy to look at this and go, oh my gosh, this is terrifying. We're sending out 90,000 lines of code today, right? But in here, we're sending out 4 million, right? And there's a lot of stress in that. And if you go, this isn't a Jez humble talk, unless you're here, Jez. All right, you can come up and talk the rest of the time. I'll let you. But it is about what he has to say, which is it's way less stressful to just know that you're going to be doing a few tens of thousands of lines of code. So we definitely believe strongly to follow master as close as possible and to just mitigate the risk as it comes out of the project, rather than let it build up for 6 months.
And you know, think about the people that are deploying clouds based on stable and just kind of waiting for this giant code dump to come along. And when they migrate to the new version, this is the amount of code they potentially have to look through when they run into problems. Like, that's the scale, the delta of things that could be the cause of a failed upgrade versus doing it in much, much smaller chunks all the time. And that was the big thing we were pushing.
Yeah, and there's more change in here than just this is lines of code, which is actually kind of an okay parameter. You don't see how in there were 15 database migrations, some of them which take hours and hours. It's much better to only have one day where you need to do those, where you do the 1 3-hour one in a nice downtime window instead of like, let's plan for the 16 migrations and have many, many downtime windows. So there's lots of change, and mitigating it was an important factor for us.
And so I think the next couple slides we kind of sail out of what we already said, but
It's like it's the first time we've done this talk together.
who could have guessed?
Yeah.
No one would.
We
You shouldn't have said that.
Oh, the mics are on.
So some of the big advantages, right? You'll be ahead of every other cloud. There for a while, and still, and to some extent, Rackspace is deploying for master, but they have pretty big drift and they're carrying a lot of local code. So there was the potential here that we would have been like the only large-scale cloud that was constantly deploying for master, which meant we had access to all the new stuff that was coming in, and we were, for the while that we were doing this, we were leaders in the community for some of the work we were doing. Disadvantage is a lot of the same advantages. So we were ahead of every new cloud, and so we were the first ones to find interesting breakage, and that it was actually happening quite a lot. We were finding things and proposing patches upstream to fix them. So we were finding things in our test deployments and getting them fixed before we were deploying out to the other regions.
Being the leader isn't always the easy path.
Yeah.
Actually, it rarely is.
And yeah. So the way we were doing it, we were using Zool. I'll go through these bullets real quick, and then I'll let Clint expand on some of this. We were cloning all the OpenStack project repos, and we would try to deploy. If it worked, we would test that deployment, and then we were doing that about every hour, I think. And the same test that we were using, basically we were using the same test all the way across. So any local change was being tested the exact same way any upstream change was coming in.
Right, and one of the top bullet is tiny and shortest, but it's actually the most important in that. Zool is a system that OpenStack came up with to run commits through really fast and not give up on any quality. So it's actually not something that OpenStack talks about enough, I think, and it's become a focus of my job every day now, and we'll talk about it later. But essentially, by us using Zool in the same way that OpenStack does, we're able to ingest those hundreds of patches that land per day, run tests on them successfully, and not have to give up on the quality, not have to shrink our test coverage. And also, we can kind of get some transitive benefit because we know OpenStack's doing this too. We can make some assumptions like we look at what our configuration is different than what gets tested in the gate, and we only have to really test that surface area really deeply. So by using Zool, in those two ways, one by depending on upstream and one using it downstream in our own code, we were able to get a huge amount of coverage and still keep the train running. It wasn't easy to get that set up, and in fact, we took a long time and several generations of upstream syncing to get it right, but we definitely mastered that, and we focused on that rather than manual testing, because if we had manual tested, we had seen this happen. Eventually, you stumble, and then the train just goes, and it's gone. And you spend the next 6 months trying to get caught up for that stable release. So we were like, we're riding the train, we're staying on the train no matter how hard it gets. And that was an extremely important part. The other part, the local commits, was actually really difficult too. If you wanted to land a local patch, you had to go through essentially more testing than if you just landed it upstream. And that was that thing we were pushing our developers to just go work upstream, because then they can just land a patch upstream, and eventually it appears in the cloud. If they wanted to work local, they had to run through all the same tests for their patch, so there was no benefit to landing things local, other than if you disagreed with the upstream community, you could land your code in our code base while you disagreed with them.
Right. But we did, it was also kind of set up to make it easier, even in the case of you wanting to do something that you might not be accepted by the upstream community. It was still easier to propose that patch upstream and get it through all of the, not even get it accepted, but just have that proposal sitting out there, and then tell the system, okay, carry this patch, like basically cherry pick that out. And then if it is accepted upstream, there isn't anything that we have to do later on. We just know we don't have to cherry pick that particular patch later on. So one more incentive for the developers to just start upstream, because it's going to be a lot more work to not. And so we were using all the same, those of you who are familiar with OpenStack at least, these are all things you've heard of. So
Who's landed a patch in OpenStack in here? Anybody? Awesome.
That counts.
It's a pretty rich tool set, but it's not GitHub. So for many, that's their open source experience, and anything that's different from that seems alien and weird, and OpenStack doesn't use any of that.
Yeah.
So the first step is like, accept Garrett. And definitely inside IBM, we were like, what's Garrett? It's a code review system.
Yeah, we talk about code review a little bit later, but just in terms of doing collaborative distributed code review, Garrett, I think, is probably one of the best systems out there for large scale.
And it comes from Android development, actually built it up, so it has a pretty long history, but it's one that maybe the rest of the open source world hasn't seen until now. It's actually getting a lot of adoption now.
It is. So then some of the other things that we used to put this together, as Clint was talking about, Zool, and we used Jenkins, and we were using Ansible. Partly it was another for us an efficiency to start off with Blue Box, some of the tooling that they had developed to deploy their private clouds, which were OpenStack clouds, and IBM had acquired Blue Box 6 months or a year maybe before we started this. And so they had a really solid set of playbooks, and I think it's called Ursula.
Ursula, yep.
And so we started with that. And I think
we forked it, unfortunately. We had to, because our release cycles were different.
Right.
But they immediately started merging things back from us, because one other benefit of doing things from master was that our deployment code was ahead enough that when they wanted to do a stable release, which makes more sense from a private cloud, they were able to basically just package up ours, put a bow on it, and make a release from that.
And then there was one last tool that we wrote. I think Greg Haynes actually was the primary author on that, which was Upstream Sync, which was the thing that kept us in sync with upstream and could bring together our local patches and anything we needed to cherry pick. And
I tried to get him to call it Upstream Funk,
but he said no. So one of the issues was the popularity of our project. It turned out that we felt we had a stretch of time to work out the kinks, and we thought we'd show it to some people and let them kick the tires, and they loved it. And it got, they really, really liked it, and we hadn't intended this. We kind of said, well, here's this thing we're working on. We think it's cool. Take a look, and we'll talk to you about it some other time. And then suddenly we started getting new committers, and people actually starting to use the system to pull in other OpenStack projects that we hadn't intended or expected to carry, and we were getting questions, and some people thought that this was a production-ready system, that it was just good to go. It wasn't.
Yeah, and in that story, the we in that case was between 7 and 10 of us on a single team. The they on that grew from anywhere from 10 people looking at it up to about 90 at one point. So you know that an influx of interest too early in a project's maturity can be a challenge.
And through that, we and through the kind of request for help and people who didn't quite understand how to use it, we understood some of the things that we were going to have to solve, some of the training, some of the things we'd have to make easy for people to consume, and these knowledge gaps. So there was a learning curve with Garrett. So just like we talked about, actually, you, I'm sure, have used Garrett. Has anyone else actually used Garrett, like to do either a code review? Okay. It's got a learning curve, especially if you're really used to like a GitHub workflow. There's some changes, and there were plenty of people that were starting to kick the tires and had no idea what to do with it, which included things like patches that were 4,000 lines of code, which aren't really, Garrett's not meant for that, and it's not the right system really. And
the human brain isn't meant for that.
No, it's really not.
Yeah.
But we saw these really giant patches coming in, and then in a friendly way, these developers, like I said, we weren't quite ready for people to be using this anyway, and we thought we expressed that. And then they started getting a little bit angry, like, hey, why aren't you merging it? Get it in there. My boss told me to deploy this week. Like, what?
I can't even read it.
Yeah. We discovered that we had taken a very, very DevOps-centric approach to all of this, because we're kind of all believers, and it turns out not a lot of people understand what DevOps is. And
you understand?
Okay, well,
yeah,
I understand at least one definition of it.
Yeah, we had an idea what it was, but certainly that wasn't appearing in the knowledge of the teams we were working with.
Yeah, and then around Garrett, the idea of collaborative code review of small patches is also a foreign idea to some people in many large organizations. So there were entire teams that really still the way they did this was tons and tons of code, and then they would get together for a week in a conference room every 6 weeks or 2 months and review each other's code. And yeah.
Has anybody done that? Like that post-code review? Good. Don't do that.
No. So that meant we needed to come up with a solution to this, and we decided it was going to be Pirate School. So we would go to these different teams and teach them about the new tools, the code review, how the gating tests worked, and really, really sell them on community engagement and fixing upstream first. And our boss, she was the one who said this. I actually thought this was you, but she really kept hammering the point that people and process matter more than the tools. And so at the heart of everything we were doing was really to bring all of these disparate teams together and get them working together on the same code base.
Definitely. And when we say, people and process matter more than tools, I think he thinks that I said it because I said it. I repeated it many, many times. He's often, we're engineers, and we want to talk about tools. That's more power for our system. But the reality was, like, we needed more people power, and we weren't getting it, and because there was too much of a gap. There was such a steep cliff to climb to join us in this sort of DevOps adventure that we weren't even able to take advantage. Even at one time, we had 90 people available to us. A very small percentage were already able to collaborate, so we needed to do something about it.
So that meant some of us were taking a road trip. We had a couple offices. The teams that were working on this were spread literally all around the world, and we came up with a relatively simple curriculum that was not what any of the teams expected, in that it was extremely collaborative. We did one pass where we had 1 day of slides, or actually a lot of it was very slide-driven, so we'd come up with our outline and everything we wanted to hit, and pretty quickly we realized that just this wasn't going to do what we wanted, so we we just didn't have slides. We had a simple outline, and it was whiteboards and talking to people, and then that was some of the stuff, and then the rest of it was just actually having them do their first commit to OpenStack and walk through some of the OpenStack upstream training and some of the other things that we did.
And the reason for that map, by the way, is the face-to-face aspect, right? We also made a
Good point.
choice after having a lot of phone calls. You know, IBM's a big company. We had people spread all over the world. And after having a few phone calls, we realized it's not that they're not smart enough. These were absolutely some of the smartest engineers in the company. It's that we don't have any way to relate on these very abstract topics. Let's get in a room. Let's get in a room. Let's get whiteboards up. Let's get this done and get a deep dive in. And that definitely made all the difference, which is why there's a map. There's also, this is the shirt from the tour. You can see we went to several different cities. And this is actually poor Jamie Lennox is from Sydney. He's on our team, so he's most of these big lines.
Yeah.
But we sent people all over, making sure that we got the right people in front of the right students, basically.
Right. And one of the big drivers was to build an internal community and get everyone working together. So there was some of the things that they loved. Is there more? Yeah. Getting people to understand what practical DevOps meant, at least for our definition, which mainly amounts to config as code and code as conversation. Getting people to recognize that, and actually setting up from the very beginning, the only way to deploy anything was through a commit. We weren't there really wasn't any way for you to SSH into any of these boxes to fix something. If something was wrong, the only way you could fix it was go back to the code base, commit something, get it reviewed, get someone else to merge it, and then the system will pick it up and deploy it and fix it up on staging or even on production. To me, what is DevOps? That's probably one of the most key concepts, and that was the thing that a lot of people were very uncomfortable with, especially even the ops people. They are like, oh no, but when things break, I need to jump on and SSH to all the servers. No, you don't. You can do it a different way and a better way.
I call it a ruthless devotion to the automation.
Yeah.
That's really what it was. There is a way into that system. I promise that we could SSH in. We're not going to. We're going to work together and land code so that we can remember why we did it that way, so we know what we did to the system. And that is part of DevOps, but that's also just part of being able to communicate with people and making sure that the conversation happens.
Exactly. And then other components of that were we were using the exact same tooling and the exact same playbooks across everywhere. So on my laptop or on anyone else's laptop, you could deploy a very small version of this cloud that used the exact same deployment toolbooks and all the same bits and pieces. And it was the same thing when it would hit staging and the same thing when it would hit production, which gave people an awful lot of confidence. And we also added tests in the gate, so everything was actually tested before it would merge, which gives people also a lot of confidence about what they're putting in and alleviates some of that worry.
Yeah, it's nice when you check out master and it actually works.
Yeah.
That's a really nice experience.
This was I think this was Beijing, and that's Jamie Lennox in the foreground and Spencer Crum in the background, who was actually here, and I don't think he spoke at this.
He ran Open Infra Day.
Oh yeah, he did. That's right. He did the Open Infra Day. Spencer was, I would say, in large part, the heart of our training efforts. He did all the hard work, and I would help him. And Jamie would sit around looking wise, rubbing his chin a lot.
We did have a structure, which I don't know that we have in our slides, which was really nice, where there would sort of Spencer was like the head trainer, and then you would be sort of the administrative, like make sure everybody has everything you need to be able to listen to Spencer.
Right.
And then in this case, Jamie was the developer, sort of the knowledgeable person to go to for the deeper questions.
Yes.
Right. So Spencer would be explaining, and when there was a question that Spencer didn't have, usually the overlap of knowledge would come to Jamie. So I did that role a couple of times. Greg did that sometimes. We always had somebody who had a deep understanding of the nuts and bolts but maybe wasn't able to be at every training,
Right.
and it worked out really nicely.
But it was, I think Spencer and I we were the ones that were at every
You were
training.
every single one.
Yes. And we had, the first day was the big knowledge dump, lots of whiteboarding, all the big topics, getting people ready, and then the second day was all lab day, and that was the day that I mostly ran, spending the time with everyone, making sure that their systems were good, that they understood how to use all the tools, and mostly force them to actually walk through and use everything while we were there, so that they, when we left, they all could launch the environment on their laptop, could check code in to change it, and understand what the implications and the ramifications were of any of the things they were doing. And one of the favorite things that I loved and saw Spencer, this was the thing that I think had the most impact that I would see Spencer do, was he would teach the levels of DevOps. And this was the way he did it is far better than this one slide. This doesn't even slightly vaguely do it justice. But to put it really simply, he'd start with the whiteboard and he'd kind of show, okay, you're a sysadmin, and he would draw a stick figure, and you're taking care of a computer, and he would draw the computer, and he would talk about, your first level, you'll learn to use configuration management for repeatable deploys. And then, what if you took that config management and put a cron on that? So anytime you change that config, it just gets automatically deployed every 15 minutes or something. And what if you put all of that in Git, and you trigger that deployment when there's an update? And then the last one is to collaborate in the code review. So he would spend 20 minutes talking carefully about this, and you'd be able to look around the room and see the light bulbs going off, and the people would actually get it. And they'd be, oh my God, this is so much better than the way we're doing it right now. And I mean, like, every single room, every single office that we went to, and every single team that we taught this changed the way they worked and got like so much more productive and collaborated so much better. And I think this was one of the things that probably made the biggest difference.
Yeah, and I think the lesson from that, pulling back from the details, was having a unified plan across these teams also helped them communicate with each other without us, which increased the amount of collaboration in general. So we all were just speaking the same language. We all understood, even though DevOps is somewhat poorly, amorphously understood, on our teams, it was this. It was this here, and you all had Spencer show it to you. So you could refer back to those concepts and pretty much know that you were saying the same thing. It had a huge impact on communication efficiency.
And like I was saying, the big key was building communities, and that involved upstream code review, getting everyone who was working on OpenStack to actually be on the OpenStack mailing list and recognize that that's where the asynchronous communication happens, and that you can, if you tune in and read or just skim some of that stuff, you'll actually have an ongoing sense of what's happening with OpenStack, and not be surprised when something you were relying on goes away, or there's the gate's on fire or whatever. And also IRC and Slack are really good for that. And we were just kind of hammering all the time to these teams that we're in this together, because unfortunately a lot of these teams were set up in a way that they just had a narrow responsibility, and they were a little bit scared because they'd been told, well, you're in charge of this slice of OpenStack. Go make it better. And some of these people didn't have any OpenStack experience prior to this, and they kind of felt like they were being thrown to the wolves. And what we were trying to tell them and make really clear to all of them was that we're actually, with every other team that's working on this stuff, and the pirate team included, we're all in this together, and that you've got a whole group of people that you can reach out to anytime you need help. And you could kind of see that relief as they realize that we meant it.
One team.
Exactly.
Just one team.
So when it came to testing and deploying, I talked about the local deployments were the same. So we would use Ansible to deploy onto Vagrant, and for staging it was Ansible onto Ironic, which would then get out onto the bare metal. And the production deployments were exactly the same, Ansible with Ironic on the bare metal. And across all of these, it was the exact same playbooks and the exact same tests. So there was no, like, oh, well, it worked on my laptop. Why didn't it work when we got to staging? Like, it worked in DevStack.
There were rare cases, right? We didn't have Viatas or NetApps on our laptops, but other than that, everything was the
Yeah,
same.
to be
So the
fair, it
idea
wasn't
was
exactly the same.
to narrow
It was
down
close.
the differences to just what's actually different in staging, so that most people could debug things in that nice tight feedback loop of actually being on your local machine.
Right. And so the end result that we saw for the developers were we had huge converts to Garrett. People really started to appreciate reviewing code that way and sharing code with their coworkers that way. And they, like I said, they got DevOps. They really appreciated CI/CD, and everyone loves Zool. I mean, everyone really, like, people really, really appreciated that. Well, Clint is going to talk a little bit more to.
Yeah, we'll talk more about
that. But yeah, and it's getting everyone to be on the same page in one big team. Is there more? Yeah. So here's one of the pirate teams. One of the things that we did was we would bring a pirate flag to every office when we were teaching them, and we would present them with the pirate flag kind of as a sort of graduation, and they loved it. Unfortunately, I couldn't find any other pictures, so I only have two from when we were in China, which was probably the most fun trip. But yeah, it was one of the things that also kind of gave them the sense that, hey, they're part of the broader pirate team.
Yeah, it was like a rite of passage when your team like took the pirate flag picture. It's like, now we speak Pirate-ese, so you can talk to us about DevOps levels, and we'll understand what you're saying.
Exactly.
Arr. There were quite a few Avasts and Yars.
There was a lot of pirate talk.
Yeah. I think we had a yard arm.
So we absolutely saw improved developer velocity. No question. Once the teams were up to speed and understood the way we were working, everyone was much more integrated, and they were able to move way faster, and they were collaborating so much better, and we had really very effectively broken down these kind of artificial barriers from these teams being geographically distributed and not necessarily realizing that we're all trying to solve the same problem, because they were also in different organizations within the company. And there were fewer bugs, and people really started to appreciate open source. So we had a bunch of people that we talked to and that we trained that hadn't really thought about open source software. Some people had been IBMers their whole life, and they mostly just thought about enterprise stuff, and they didn't have a great appreciation for what you can do with contributing back to open source software and how important it is to be a part of that community of any of the software that you're consuming.
Yeah, there was a follow-on thing that would happen that had nothing to do with Pirate Cloud or even OpenStack, which was that we had a number of contributors from every level, like you said, people who had been at IBM since they were in college, up to people who had just started at IBM the week before, who would come up and say, I've always heard open source, I've seen open source, I've even used open source, but I never got that I can actually collaborate with other people and get something real done. And that I had at least 4 or 5 people come to me and say almost the exact same thing, which is this was inspiring on a level that didn't matter about my day job. There's actually people out there collaborating on good things, and it sort of gave them a morale boost to be involved with that. So
this is your slide.
This is my slide. So another thing that was an end result for IBM is we had all those positive reactions to Pirate School, and people worked once they had Pirate School, and once they saw the song and dance from that, they actually worked on Pirate Cloud for several months, and we did some retrospectives. We asked, what did you like, what did you love? And there was a massive amount of people who said, I really loved working on this CI and CD system. So basically Garrett and Zool and that level of testing, they hadn't had that experience. So we kind of thought if we could forklift that chunk of the DevOps experience into something more generic, we might be able to do some good, not only for IBM, but for the open source world. So it's a poorly understood idea, but it's become my job to explain it to people. But Zool enables much higher throughput of gated code. So has anybody contributed to a thing where you have to pass the test before you land right? And there's one universal problem with that, which is that no matter what, if you have to pass the tests, however long the tests take is how long each patch has to wait before it can land. And if you have 10, 15, 20 patches waiting, you have two choices. You can either land all of them at once and hope that they work together, those in-flight patches, or you can serialize them. And now if you have an hour-long test suite, you have 10 hours to land a patch, which is not fun. So what OpenStack did was actually make a system that parallelizes that, and we used that to great effect during the Pirate Cloud, in that we could now decouple approving patches and landing patches and testing patches, so they all happen as fast as they can. And we use the cloud to do that. So we run parallelized testing to an extreme level, even in gating. I would be happy to explain that more in depth when we get to Q&A, but I want to make sure we let people get to the end. We also have cross-repo dependencies. What that means is if I'm working in project A and I realize there's a bug in project B that prevents my feature from landing, normally what I have to do is go land the fix in B, wait for the fix to release, wait for it to get available, and then it gets shipped. With cross-repo dependencies, I can say, whenever that lands, land mine too. And so now I get to like build the future I want and wait for it to happen. So those two features are actually in Zool, which is basically a replacement for Jenkins, and a pipeline manager for CI. And then Bonnie CI is Zool as a service for any GitHub project. We're in super closed beta right now. In fact, our first closed beta user came online the other day, sort of, and reported lots of bugs. So thank you to that intrepid person. But we're definitely wanting to have the conversation. So if you think that sounds interesting and you have a project on GitHub where you want to be able to gate code and you want to be able to have cross-repo dependencies with other projects, totally go to bonnieci.org or just come find me and say hello, and we can play with that.
Or if you're familiar with IRC, get on Freenode.
Oh, right, there's a #BonnieCI channel as well, and you can do that. Also, we have a GitHub org which is linked from the website, BonnieCI, and you can see all of our deployment code, because we're all people who work on open infra projects, so we are an open infra project. So you can go see all of our Ansible, and you can help us improve it. You could even use it to deploy your own Zool. And also possibly we might be able to take your project if you're on Garrett Hub, but that's we'll have a conversation if you're actually on Garrett Hub, because we just love Garrett.
So we end this by encouraging everyone to do some of the same things that we did within our organization and hopefully affect some change there. So, educate top down, demonstrating the value of open source and open processes. And you don't have to use the exact same tooling as long as you're doing some sort of collaborative code review and CI/CD with tests. And there might be, that's it.
Any questions?
Question was, did we only do this in IBM offices, or did we go around to outside offices, companies outside IBM? No, this was only internal. This was IBM. What we were doing was bringing, in some sense, the same upstream training that OpenStack Foundation does at every OpenStack Summit. We're bringing that into IBM and showing the IBMers how to use the tools and the systems that were inside IBM.
There was another question.
So I'll repeat the question in case this is actually being recorded, but the question was, how did things work with the different orders of services and things that had to go?
The answer is terribly. OpenStack is super complicated. It's a large-scale distributed system, and even though you would think that there was one agreed upon way to do anything, there are 50. We absolutely tested every change, including changes to the ordering and the upgrade code. We didn't get great at doing certain types of updates, and we would have to sort of manually hold those back. So in that graph I showed where we were doing 10,000 lines some days and 40,000, there were times where we basically had our test staging deployment was really picky about if it changes the database, it explodes. And we would just have to manually go look at that and say, how is that going to go? Are we going to be able to just let that run? Or is that going to take 17 hours in production, and we can't do that? We have to schedule downtime. We never actually got a lot of users on the cloud while we were doing this, so we never had to make the decision to manually hold one back more than just, okay, that's fine, go ahead and land the change that allows that version to go forward. But it is very complicated to keep an OpenStack system up and live and running while you're changing the code a lot. We also landed a lot of patches upstream in OpenStack to make that work better.
So like in terms of like trying to upgrade OpenStack, like what are like I guess best practices you can get on to like when we do upgrade OpenStack, because that person lives like horror stories about trying to upgrade OpenStack. So maybe you can give some pointers I guess on how best case to do that.
The question was best pointers and best case scenarios for upgrading OpenStack and best practices for it. So, I mean, the first question is what distribution? Because the truth is, it's different with every distro.
Yeah. Right now, well, this is pretty much
So using like charms and Juju to deploy it, or the Ubuntu packages and deploying it with your own deployment tooling.
Read the manual? Sorry, I did not want to say that today. I try not to say it. So your problem is that you have 9 million lines of code to change, and you're not sure which ones actually change your deployment, which is exactly the thing CD helps with, because at least you only do 10,000 at a time every day. But some orgs aren't built to have CD.
Yeah, and it doesn't help you today.
It doesn't help you today. So we're not good at talking about stable release updates because our whole being is to try and avoid to ever have to do one. So I don't have a good answer for you. Yeah.
How do you deal, or how did your system deal with persistent data? I mean, are you, in these upgrades you're rolling out every Tuesday and Thursday, you're upgrading Swift and what have you, or you have, some sort of NAS appliance off to the side keeping all the data? Now, granted, I assume there's like external Git services and stuff like that to pull in, and maybe repos and what have you, but how much is in the system?
Right.
Persistent data is in the system while you're upgrading the system.
So the question is, how do we handle persistent data during upgrades? So it's important to note we were deploying on about 1,000 servers with their own local storage, and we were not deploying Swift. So we did have Cinder, and that was stored on NetApps that were out of our control. Actually, we were basically just given an NFS mount, like put your volumes here. So we didn't even have that in our sphere.
No, but I guess the other problem too is as you were moving the code you had control forward, your Cinder's kind of falling behind.
No, we still.
No, the code
Cinder
was always updated.
Right.
The code. The Cinder code, okay.
Yeah, the
admin rights to the NetApp.
Sorry?
You didn't have admin rights to the NetApp. You were just here, dump your playground here.
Right. Yeah, and so NetApp was just as far as we were concerned, just a disk that Cinder was in front of.
And then the disks on an individual compute node are what they are, which is important user data, but not related to the code in most cases. We one time had an update to QEMU, which our QEMU, and had to look and see if it would change any of that, and it didn't, so we just rolled forward. But everything we're talking about was code rolling forward. The only data that we really had to worry about was actually the control plane data. The user data essentially, like OpenStack exists to kind of make sure VMs run and you know where they are and where the data is. So it does that pretty well. And we didn't do any live migration. We never had to go through a reboot of compute nodes. The plan was to essentially just have downtime windows. Tell users your VM's going to reboot tomorrow. Sorry.
The Tuesday and Thursday down, or was it Tuesday and Thursday?
Those were
and then start rebooting stuff.
Those would be control plane windows only and downtime windows only, and we actually never had to open a downtime window for those because everything we were updating was basically rolling updatable.
It didn't impact the VMs themselves.
Yeah,
Yeah.
nothing impacted the VMs. Yes? So we were using, the question is how we were using Ansible to talk to Ironic in our build step, because we did say we're using that. There's actually a project called Bifrost, or Bifrost if you're Swedish. I like Bifrost actually, it just sounds delicious.
Bifrost, I think.
And that is actually a project where the people developing Ironic noticed that it would actually be useful without the rest of OpenStack in bootstrappy instances. So it's like Ironic is very good at talking to all kinds of bare metal servers, and you don't necessarily need image management and auth management and volumes and network SDN. You might just need something that's really good, basically a cobbler replacement, if you've ever used a cobbler or razor or anything like that. So we were using it. We had a set of Ansible playbooks called Bifrost that just used the Ironic API to deploy bare metal nodes with basically just a base image. And then we would use Ansible to layer on top of that. IPMI. Seems like that's it.
Thank you, everybody, and thanks for coming to SCaLE.
Yeah.